Hi, team. Very good morning and good evening, all. So let's get started, team. Okay, so we were looking into the SQL basics, right? In the last week, even I have covered the first two SQL sessions through the video, and the third session that we had on the last week is more related to the very core basics, right? Which is all about like we were executing few things. And I hope like you guys got a chance to execute from your side also the same set of SQL queries. Is that correct, team? You guys are also following the same kind of SQL execution from your side also, because that plays a very important role, especially in terms of writing SQL. I know like some of you guys are facing, see, SQL is a very simple language and it is like an English like kind of language. As you see all this, right, what we discussed in the last week, all are like an English words, right, that we are farming. So select all the columns from table, right? Or select few columns or select a set of data from all the columns from the table with a given set of rows. So what you have to basically consider is we have to imagine the data in the form of rows and columns, right? The columns will have data types, the rows will have the heterogeneous data in a form of like differential data types, and we can use the column names as a specifier to specify the list of columns to get it queried from the table. Where in the background, how it works is the data will be stored in the disk of the underlying database server. Whenever you write a query, the data from the disk will be brought to the memory, the RAM, and then it will be applied with the computation. Then whatever the column that I expected from the RAM, it will be produced as an output in the screen, or maybe it is produced as an output to another table or whichever it may be. So that is how basically the SQL queries that works in general. That's what we have understood over in this list of queries, where specifically if you look into, we have to understand about, like how do we perform some sort of like sorting operation, and how do we perform some sort of like a sorting operation in an ascending or in a descending order, or how do we perform some operations in a filtering operation. The filters comprised of multiple concepts like operations or not like operation, kind of in operation, not in operations, like couple of filter operations that is available in the queries in general. Then we were talking about the date level of filtering. The date can be applied with greater than or less than symbols and all. And like operation is working in MySQL also with respect to the data operation. If you put a like, it works as well. So some of this kind of like operators and all we were seeing. So basically how you have to recall this program or a query in general, you have to register. I don't always ask you to memorize and all certain things, but the SQL side, as I told in the first initial videos, I wanted you guys to go and memorize certain things in terms of the syntax. So always you don't have to refer some document or some online medium and all, always for referring the syntax. So you had to know about the basic syntax of writing SQL queries in terms of the select, from, where, group by, order by, having, or group by, having, order by, limit, like this kind of order in which you have to write the SQL that you have to recall, and what are all the classes we used to call it as. So how many classes we have here? Select class we have here. From class we have here. Class, we used to call it as class. So the some of those kind of basics we have to understand primarily, and this set of queries what I created is mainly to make you guys do the execution. Okay, and I hope like you guys are all trying to do some sort of execution, especially with respect to nulls and all, plays a very important role. Null means I don't know the value of it. So I'm just going to say whichever the value that I don't know, I am going to have it as considered as a null. The null means nothing. I don't have any input on what is that values. So that is all about null. Then we were talking about some distinct keywords. So this is a very basic level of SQL that all we have to know for sure. Second level, we were talking about the join functionalities. So I discussed with you guys related to this basic core types of joins like inner join and outer join. There are two major types of joins are there, inner join and outer join. Inner join represents what? Basically what is join is all about. If I have data in two tables, I wanted to connect those data. I'll use some common column, one or multiple columns to join the data between the two tables. That's the core concept of join. In the join, what we do, basically, we go and select the columns from table A and table B, or only table A or only table B, whichever we can select. And we will be mentioning from the table A, join or inner join or left outer join, right outer join, full outer join, self join. Self join, we don't use it as a keyword. Like we'll majorly use this keyword as inner, left or right outer join. These three keywords we majorly use. So in some databases, we have something like a full join also, full outer join like this also we have. But in general, I'm putting a join means it is nothing but an inner join, because inner join is primarily used most of the time, and left outer join is the secondarily used most of the time, the join condition that we use. Other than that, not all the joins we always use, but we are going to learn extended joins and all in our subsequent learning. But for now, if you say, Irfan, I know how to write a join. How? Basically, you have to go to the SQL environment. If you say like this, I know how to write a join, I'm well and good. So you're going to say, I want to go to a particular database. Use the particular database called learning DB or whatever. This is like I'm double clicking a folder and going inside a folder. Inside the folder, we have two tables, department and employees. These two tables you can consider like a two Excel sheet. I'm going to say, I want to select the data from department table or employees table. And I want to select the data from department table. I'm selecting the data from two different tables. If you go through these tables, you can able to find what is the common column between these two tables and what is the category of this table. You have to first understand. The category of this table is a detail table, and the category of this table is a master table. So you can say this contains the department master information. This table contains the employee master information, but it has the details of, it has the one-to-many connection between the department and employee. You can consider like that. So one department can have multiple employees. That's what the ER diagram we discussed in our data warehouse discussion and all. When we create a data model, we'll understand the relation between these two tables like this. This is one and this is many. This is how we'll have the relation created. This is how we create the relation between these two tables. So now I'm going to say what? For one department, I may have multiple employees. So I can expect all the records from employee table, and I can expect the matching department information for the employee. So what I wanted here is, I'm going to say, yeah, I wanted to see all the data from the employees table. I'm seeing that. But this contains only the employees core information, employees basic information. We don't have the department information of where this employee is working. In order to get that, I have to go and either take this number and go there separately, and I have to measure what is the department value of 90. Oh, this employees list of employees, whatever I have seen, are belonging to executive departments. They're all executives, or they're all executive department in two. Rather than I say, I'll go and join these two tables as E. The alias name I can give as E. Inner join the data from departments table I can mention with the join condition, on condition of the E dot department ID. What is the common column between the two tables? Department ID is equal to D dot department ID. By this way, when I mention, it will go and show the data from both employees table and the department table. Since I put just star, it will take data from both the tables and display. Both the tables and display. First table will be employee table until here. Then the data from the department table will also be displayed. But this is called one-to-many relationship. Why? Because the department ID 90 of all the employees will be shown with executive repeated data. Which location they belonging to, or what is the department ID and name of the department, what is the manager of this employee, all this information is given there. So this is inner join, which represents what? If I have 100 employees with all the matching department in the department table, then it will show all the 100 employees information. But as we have seen in the last week, I had some of the employees who don't have matching department. So if you see, there are around 30 records are returned back to us. I'm just quickly recapping our last week discussion what we made. So in the employees table, if you separately measure, we have how many employees? 31 employees. So it seems to be like one of the employee does not have the matching department. As per our last week data that we generated, one department ID called 1000 is there for an employee. For the employee called Adam Fripp or somebody. This 1000 department ID may not be present in the department table. There is no department ID called 1000 in the department table. So what happened? When I use inner join or an EQ join, we used to call it as, whichever the non-matching departments, 1000 is not available in the department table. So what it is going to do, when I use an inner join, only the matching data between employee and department will be shown. So the employee with the like a department ID of 1000 will not be displayed if I run this query. The employee without that or with the department ID matching alone will be displayed here. If you find this, since there is no 1000 department ID in the department table, it could not able to match and show the result. So that one employee is missing here. 31 employees that we are supposed to see, but only 30 employees are being shown because of the particular department is not present in the department table. Because of inner join I'm using, it is not shown as an output. But I want to put a left join. What will happen? All the data from employees, regardless whether it is matching with the department ID of the department table or not, it will display all the data from the employee table. So how many records will be displayed in our case? 31 records. So you can see 31 records, including that 1000 will also be shown. The department ID of 1000 will also be displayed. You see here? The department ID of 1000 is also displayed from the employee table. So all 31 records from the employee table will be displayed. And whatever the matching data from the department will be displayed with the data. Whatever the unmatched data will be shown as null. This is basically the concept of left outer join. Left outer represents what? The left side table should provide all the data. Right side table should provide the data for the matching column values. For unmatched column values, show the null. That is the core concept. That is the core concept of left outer join, what we discussed here in this sheet. In this sheet, we discussed about that. Okay, let me open the sheet here. We discussed about this concept here. We are using some columns to match the data. If I go with the left outer join, what happens? All the data from the left table will be displayed. The matching data from the right table will be shown as null. If I go with the right outer join, what happens? All the data from the right table will be displayed, and whatever the unmatched data from the left table will be shown as null. In our case, we have that kind of scenario also last week created. If you take the department table, one more department we added in the last week. That department ID is called 999. That is Research and Development Department. So that Research and Development Department, R&D department, is not present. None of the employees got added yet in the R&D department. No employees are added in the R&D department. You can see this department ID does not have the value of 999. Now, what I'm going to display? I'm going to display right outer join by saying what all the data from the right department table you display, including that 999 also you display. The unmatched data of the department, the employees, whichever is not belonging to 999, right? Show that value as null. So in this time, we can see the left table with nulls. You see here? There are two departments seems to be not present in. In fact, there is no employees belonging to 10 and 20 department, it seems. In addition to that, we don't have employees in 999 department also, which we created literally. Even some departments are not belonging to these also. Some employees are not belonging to these departments also. So it is showing what? All these employees are not belonging to the department. So how can I prove that? How can I say, hey, which are all the employees are not, or which are all the departments are not having employees? This is the entry question asked. There is an entry question. They may ask, people may ask, right? What is that? Hey, I'm having two tables, maybe some customer and product table. I want to know which are all the products are not purchased by a customer. The same question. Employees and department table. Which are all the employees are not, or which are all the departments are not having an employee? Which are all the products are not having customers purchased it? So what I had to do, I had to write. The question can be, which are the departments don't have employees? I have a department formed in my organization, but no employees are working there yet. How can I identify that? I'll go and put a where condition of saying where E dot, maybe some column, any column you can consider, or E dot department ID is null. If I ask like this, it will say, Irfan, which are all the departments excessively that is present in the department table that does not have an employee data? So employee table side, what all the data is null? I want to know that. So if I put a query like this, it will show all the departments or all the department which does not have an employee at all. So this many departments are not having employees at all in their department. Now let me ask you one more question. The interview question will be like this. You have to think about how to write it as a query. This is what we are going to do next. After a few minutes, we are going to do this. Which are all the employees are not assigned with any departments? If I ask like this, all I have to do is what? Rather than write out rejoin, I need all the employees from the employees and departments I wanted, but I want to see which are all the employees don't have department ID. So I will say department table department ID is null. So what it will do? It will give me all the employees information who don't have departments. Oh, there is one employee called Adam Fripp is there. This guy's department ID is 1000. I'm having an employee, but he's not having a department at all. He's assigned with an department which is not present in the department list. Which are all the employees are not having or not assigned with the department which is not present in our organization. Maybe it could be a wrong mapping also. This department may be in some other company it may be there, or it can be wrongly mapped. Like we can able to identify. Okay, there is one more question, mix of both. Mix of both above questions. So show me which are all the departments that don't have employees, which are all the employees that have the department which is not present in the department table, the vice versa. So this is the place where we use full outer join, but we were realizing like full outer join as such in this MySQL, it is not supportive, but it is supportive in other databases. In all other databases, it is supportive. Full outer join is not supportive here. So what I had to do, I can't achieve by using full outer join. I had to take a different scenario to achieve this. So I want to show the excessive data from left and excessive data from right also. That is the case. So if I go with inner join, what will happen? Show me exactly the reverse case of this. Show me exactly which are all the department have employees, which are all the employees have the right department assigned. If that is the case, then I'll go with inner join, which will exactly show me no nulls in the department or no nulls in the employee or department table. No nulls it will show. So this condition, if I put, it will not return even one record. If I put this condition, even it will not return one record because both are matching. When I give inner join, it will ensure both department matching data alone I will bring. I don't bring excessive data. Left side excessive data, right side excessive data. This is the core concept of join. Join is a tricky concept, but what you have to do for learning join, first you have to go and create some sample data. Then you have to understand the concept of join as we did in the last session. These two data sets are there. Few employees are assigned with the store, which is not already present in the store table. Few stores are there, which is not having a customer at all. Like this, vice versa, we can have. And we can understand. When I do left join, all the employees will be shown from the left table. All the customers will be shown from the left table. Whichever the non-matching stores that we have, that will show with the null values. Matching store will have the values. And one-to-many join we are doing. One store can have multiple customers. Inner join when I do, only matching store data will be shown from the employee side also. The unmatched store information will not be shown. Cartesian product when I do, that's one of the pretty interesting question. If I miss the join condition, then both data will be multiplied. If I have 30 records in employees and 20 records in department, it will return 600 records. It will put all permutation, combination and returns. Both count will multiply and say the result of this count. Okay, let me tell you one important interview question, which like when you attend even as a data engineer, it's not a SQL question alone. It's even a data engineering question, a simple data engineering question. They may ask, I have two tables. Table A with 10 records, table B with 5 records. Okay. In this case, I'm going to do, in which the table A and B are going to be matched with the A may be matching with the B with 8 records. And B may be matching with the table with 4 records. 1 record is excessive in B. And 2 records are excessive in A. So when I do inner join, how many result will be found? When I do inner join, what will be the result? When I do left outer join, how many records I'll be getting as a result? When I do right outer join, how many records? When I do full outer join, how many records? When I do, like a Cartesian product, how many records? At least, they can ask more question on this, anti-join, semi-join and all, that we'll learn later. But this is a potential question asked in interview. So when I do inner join, how many records will be returning? Only 4 records, because both sides, we have 10 and 5. Whatever the matching record will be returned. I'm telling, we have 8 and 4, where 4 are matching, or 8 is matching. So it will return 8 records. 2 employees belonging to each department, 2 employees are belonging. One of the employee, there is no employee, one of the department, no employees are belonging. So 8 records will be returned. Left outer join, if I go, it will return all 4 records. All 8 records. Like this, we can see the results. And right outer join, 4 records, as Ravalis mentioned. Full join will return the data from both the tables. It will return 10 records as per this data set. And the Cartesian product will return 50 records. 10 into 5. No, I'm not talking about the matching data. Here, you can see this is the actual data. Actual data. This is the kind of a matching data. 8 and 4 are matching. 8 employees in 4 departments. But actually, we have 10 employees in 5 departments. 1 excessive department and 2 excessive employees are there. So in that case, how it will be matching? Inner join, when I do 4 records. Or if I have 1 too many join, then 8 records will be provided as an output. That's where I put 8 or 4. As depends upon the data what we have to check that and answer. But this is how a simple calculation what you have to make, how the join works. However, we learn about join subsequently, right? But try to understand the syntax of how we use joins, right? We should not get confusion on the syntax. And as I know, like I heard from a lot of people saying like, Irfan, I found a challenge in learning the scenario-based questions in SQL. That is where the interview will go with, basically. Like this, we are going to see a lot of scenario-based questions in SQL in the form of quiz, in the form of even execution that we are going to do, in the form of maybe like use cases and project execution. Also, we are going to talk about a lot of scenarios. Even here itself, I have a couple of scenarios I'm going to discuss with you guys. But for now, at least if you understand the joins, take it forward. Okay, let's move forward with that. Okay, team. So the join of left outer, right outer, inner join, some concept called self join is there. Okay, I'm not much interested to talk about that, but there is a concept called self join is there. I can relate the same table again and again. So I can just say inner join of self join means there is no separate concept called self join is there. If I join the same table again, where or on E dot employee ID is equal to E1 dot manager ID. I want to know who is the manager of the given employee. This is a kind of a bit tricky, like SQL. So I want to know E dot, employee ID, comma, E dot employee name, comma, D dot E1 dot employee ID, comma, E1 dot manager ID, comma, E1 dot, maybe like first name, last name, whatever you can consider. First name, last name you can consider. So now when you go and see, this will show you who is the manager of a given employee. So here it's a problem with the semicolon we have to terminate, okay? So you can see the employee ID 101 has a manager called 100 as a manager. So the Stephen or Nina is the manager of Stephen. Lex is the manager of Stephen. Alexander is the manager of Lex. Like this, you can able to find who is the manager of whom within the same table you can query and see. So if I go and query this table, you can go and see the table. Employee ID 100, who has a manager of 101 employee ID. The manager of Stephen is Nina. Manager of Stephen is, Stephen is the manager of Nina. Stephen is the manager of Lex. Like, how do you find that? Let's go and see. 100 is the manager of 101 and 102. So King is the manager of, Stephen King is the manager of, the employees Nina and Lex. You can find that. Who is the manager? Stephen is the top manager. He's the manager of the Nina and Lex. How do you say? Oh, the Nina has a manager ID of 100. Lex has a manager ID of 100. The Nina and Lex are reporting to Stephen. So you can do this join to understand who is the manager of whom. Like this is a literal example of self-join in general. One thing, team, very importantly, right? This employee department is the best tables for understanding the concept of SQL in general. So that's the reason I have taken this as an example. However, we are going to see a lot of other data sets, other tables and all in our learning. This employee and department which we are using here, right? That is a best example for understanding all the concepts of SQL in general. So take this into consideration and go and learn simply sitting and trying. Okay. So what you can do, take this data, put it in an Excel sheet, save it in an Excel sheet, or I can give you this data also in an Excel sheet. Just to take this data and compare. You can just go and export this and compare in a CSV format. Take this data, keep one more data set, open one more tab even. Try to manually see how the data looks like first of all. Right? So this employee contains 30 rows. When I do the join, I can't see, here with one table, I can't see all the data. Department information of the employee, if I want to see, I had to go and join with the other table. That's the core concept of why we go for join. That is one reason behind. I want to see the data between two tables, multiple tables. We can do joins with multiple tables. One more reason behind join is I want to relate the data between one table and another table, not for viewing, for understanding the outcome out of it. For example, I'm going to join employee in the department table and I'm trying to find, hey, if how many of the employees are not having department? How many of the department don't have employees at all? How many of the departments are running without employees? Like this, I want to have a correlation between the tables. I can use this join condition. Or I wanted to perform some operation of filters. Hey, who are all the employees belonging to administration department? So what I'll do, I'll go and join the tables. Employee in the department tables, I'll join. And I do what? And I'll put a where class of checking for E1.department name is equal to accounts. By this way, I'll go and check. Administration. So how many of the people are belonging to administration department? Something like this I do. So it is not only for expanding and seeing the data. It is for all these purposes. So there is no people belonging to administration department, it seems. Then let's take some other department where the people are belonging to. 90 is a department. Let's see what is 90. 90 is executive department. So there are people are belonging to executive department. I want to see who are all the employees are of executive department. You can able to find. Right, team? So the joins are used for multiple purposes, not only for relating the data between two tables and see, right? Not only for collating the data between two tables and see the output. It is used for multiple other purposes. Right? It's used for all those purposes. Okay. So, like left outer join, right outer join. I hope you guys got it. Let me move to the next levels. Okay. How do we decide which table should be the left and which table should be the right? See, there is no thumb rule and all for that. Whatever the table that you wanted to take the major portion, you will consider as a left. Whatever the data you wanted to extend, that you have it as a right. That is the core concept that we use, Sounder. Basically, the master table, the core table that you are going to use will be kept in the left. For example, you remember like we had a, like a data warehouse learning that made. We had a fact table. The fact table will be surrounding with dimension table when we join and get some result, right? For example, if I take some data warehouse table that created by Kasi. Kasi have created fact loans, dim employees, dim customers like this and all, right? If we see this table, we have loan ID, we have customer ID. So we can connect with the loan table and the customer table. We are able to find that very directly. Customer ID is there, so we can connect with customer table. Loan table is there, we can connect with the loan ID. And we have what other column is there? Employee columns are not there, so we can't connect with the employee table. But branch column is there, so we can connect with branch table. So by looking into this table name itself, to some extent what I'm doing, I'm going to find select star from, first of all, I'm going to find the data from fact loans. EDW DB dot underscore Kasi dot fact underscore loans. Limit 100 records I'm taking first of all. There are 4 tables we are going to join now. Oh, there is no data. Okay, that is okay. Let me go with somebody else who had the data loaded. Divya have tried with employee department. Great. Everything with employee department you have tried, it seems. Most of you guys have tried with employee department, it seems, right? Some other data warehouse table is there. Okay, let it be. I'll go with this table what Kasi have created. So what I wanted to do now, right, Soundar? I have the fact table here. The fact table will be surrounding the dimension table. If I create a join like that, we call it as what model, what schema model? One fact table in the center surrounding by dimension tables. We call that as what? Star schema model. Great. So I'm going to say what? Hey, I wanted to take all the data from the fact table, comma, I want to take the data from the dim loans table also. I want to take the data from dim customer table also. I want to take the data from dim, like branches also. Like this, I want to get a result of all these tables in one screen. We call it as what type of data? Denormalized data. We call it as a star schema. The table that is going to produce me the result is a denormalized table. Like with the weekday team yesterday when we connect, I was showing you this Pothys data set, right? I have created that Pothys data as a denormalized data. One single view of data I created, like a fact table, right? You remember? to make it very simply, simply understood, right? That is how what I did yesterday, right? Let it be. You will consider like this. And you are going to do what type of join? You are going to say left join. Why? I want to see all the transactions happened in the table. Maybe some loans, whatever the customer may have taken, may not be having an branch, may have taken an online loan or something. Some table might not be having, even though it is a loan transaction, but it is not considered as a loan, it is considered as something else. I want to know all the data from the loans table. Following with that, what I'll do, first I'll go with the major table, what I wanted the data from. I wanted to then extend some of the other tables. So I will add rest of the tables in the right side. The major table, I'll put it in the left. And subsequently, what could be the important table here? Fact loans is one important table. The second table is dim loans, the detail about the, the dimension data. The dimension data of the loans I'll be collecting next. Dim loans I'll collect next. DL. Then I'll do a left outer join again with another table. That is, so first I'll be doing a left outer join with fact loans and dim loans with what condition? On fact dot loan ID is equal to dim loans dot loan ID. Then fact dot loan ID is equal to dim loan dot dim, not dim loans. I'll take second time. What table? Dim branches let me take, or dim customers let me take. So fact dot customer ID is equal to dim customer dot customer ID. Like this, I will go and make the joins further. So first I wanted majorly the data from the loans table. Then I wanted the data from the dimension table of the loans, which contains more detail about the loans. This is all fact data. These are all the dimension of the loan. And some customer related information, who taken the loan, I want to know. Then I want to know about one more table, that is dim branches. Which branch have given that loan, I want to know. You are with me? Sounder, you understood? Branch ID I'll be taking. Like this, I'll go and execute my query. We can use right outer join by keeping major table in the right. True, but basically people will not write a right outer join. The reason behind is you want to see the data in the left side or right side by going into. If I keep the data in the, if I show the data, for example, let's take this itself. This itself you take, I'm going with the left join. You tell me going with left join seems to be more presentable, or going with right join is more presentable. Just look into this and tell me, okay? Look the output and tell me. That's a great question. So you just see this output. You tell me this data looks much better, right? Where there are a lot of employees that they don't have. I mean, few of the employees, they don't have department assigned. Okay, great. If I put a right outer join, where all the data from the right table will be displayed, but data which is matching from the left table will be displayed with the rest of the data is null. So now you see which is looking more appealing for you. Which one is making you feel more appealing? Oh, left data may be having deficient. Let me go with the right data to see the sufficient data. You have to scroll and see the right data to see the data what you are expecting, right? But most of the data in the left side is null, means you feel more comfortable with left outer or right outer in general. Both are going to work in the same way. Both are working in the same way. With me, Sounder, you got the answer? Now you agree, yes, left only. But I'm not telling you have to only bias on left. No, you can go with right outer join also. As you asked, correct. That is logically correct. But outcome wise, I'm telling, right, keep the keep all the tables in the first, whichever you are feeling more prioritized. So here I'm telling, for understanding the detail about the loans, I need the dim loans first. Then which customer have taken, I want to see the customer table next. Then which branch they have given the loan, I want to see the branch information in the last. So it depends upon how the data you wanted to present. Clear? That's a great question. Okay. So guys, try like this and all in your environment, right? So that will give you a great idea, right? But as I told, right, left and inner is more important than any other joint that you go. Even I am not putting this as an important joint. Left and inner are very important. If you know left and inner, you can play around with joints like anything. Self join, forget. I'm not interested in talking about self join, but since I talked about left self join, let me put it here for your reference, right? Self join. What is self join represents? Display the matching data within the same table, join using inner join. Join the same table with an inner join to find the matching data between the given table itself using some columns like employee ID and the manager ID. A literal example for self join is this one. So I'm not telling you to know about the self join for sure, but take it as a opportunity to understand what is self join. So I wanted to know how many, the employee and his manager information in a single view. Otherwise, we had to put an effort of doing what? If I want to know, hey, this employee who is the manager of this employee, I got to put an effort to understand. Oh, this employee has no manager, but this employee is having a manager of 100. And this employee, 103, Alexander, has a manager of 102. So AD, Associate Director and VP, the IT programmer, Alexander, is reporting to Lex. And you can see this guy, Bruce, David, Valli and all are reporting to 103, Alexander. Like this, you can able to correlate here by looking manually. Rather, I'll go and do a join between the same table to see the result much wider. This will help me to understand who is the manager of whom. Very easily I can able to identify. You can go and add the job also to understand. What is the job of this employee? E dot job ID I can add, and E1 dot job ID I can add. So this will give me a better clarity. Okay. The job ID of the current employee is Associate Director, President, and he is a VP. Okay. The IT programmer Alexander, or maybe we can take this one, right? This Lex, who is having a manager of this Lex is 102, who is having a manager of, what is the employee ID I have taken? Employee of the manager table, right? Okay, yeah. So this Stephen is reporting to, or Nina and Lex is reporting to Stephen. The employee ID, I know like 101 and 102 are reporting to 100. 103 is reporting to 102. 104 and 5 and 6 are reporting to 103. So like this, we can able to understand it very easily. So these people, IT programmers, like these people are all reporting to Alexander. So I can say like who is reporting to whom in a very easy fashion. So Bruce, David, Valli, and Diana are reporting to Alexander. Like this, you can able to relate. Since it is showing as IT programmers, all of them, you can consider maybe like in a better way, like this one. F1 manager, Nancy is the F1 manager, FI manager, and FI accounts people and all are reporting to Nancy. These are all FI accounts people reporting to Nancy. Like this, you can able to see the better view of this data by using self join. Self join is the same table I join himself. Okay. So Any other, somebody asked any more question? No, right? Okay. That's a great question. What Sounder you have asked. Okay. We can have a right join. Okay. That's a great question. Okay. So feel free to ask the question, guys. Okay. In on condition, we have to mention only common columns between two tables. You see, common columns means it is not supposed to have a same column name and all. The column that can be used for connecting the data, that we have to consider. It's not supposed to be, not every tables may have a common column available. Right? We can use some related columns, correlated columns. We can't say the tables may have the same column name between. You can have any column name, but the data should be matching. That's how we have to consider. So here I'm telling manager ID is also an employee ID only, but that's a manager ID. So I'm using this column to join. Okay, you are with me, Sounder? So basically we join the tables by using some common columns only. I can't use customer ID joined with loan ID. That is not possible. That is possible syntactically, but semantically it is not possible. It won't work in real. Okay. Yeah. So Sukumar, you have any question?
Sorry, Irfan. Yes, I have a question. Though you mentioned self-join, that is not that much important, but I have a question to self-join only. So, Irfan.
Yeah, go ahead.
So there is a scenario to find an employee who is getting a salary more than their manager, right? So I have a little confusion in the on condition. For an example, so we are matching the employee ID, right? E dot employee ID is equal to E1 dot manager ID. So in my SQL query, they mapped like E dot manager ID is equal to E1 dot employee ID. So then only it is giving us a correct result. So if I match this employee ID, that time it is not giving the correct result. So
no, you are telling like you are putting E dot manager ID is equal to E1 dot employee.
E1 dot manager, yes, correct.
That is okay. See, I'm just putting a join in general. You can keep this as a first table, this as a second table. Anything you can put. I'm not telling wrong about that. Yes,
No. So they keep only, for an example, from employees you keep alias name is E, right? And after joining another table is E1.
Yeah.
So in E table we have an employee ID. So E dot employee ID is equal to E1 dot manager ID. In this case, it is not giving the correct result. So if I keep E dot manager ID is equal to E1 dot employee ID, that time only it is giving a correct result.
That depends on how the data is organized. Okay. Let us see this data, right? Let us see this data. So you can see here, these are all the employees, right? Are all reporting to these people. So we are having the column order differently earlier shown. That's the only difference.
Okay.
Otherwise, you can find the result, right? This guy is the president actually. The Stephen King is the president of this table. If you see this one, right? This is showing the right result only. But how you are seeing the result is, how you are seeing the data is important here. So if you see here, the direct table, if you go and see, you can find here, Stephen King, right? He is the AD president. He's the president. He don't have a manager ID at all. Right? And in addition to that, right, if you take this guy, Nina Kocher, she is having a manager of 100. 100 is Stephen King. 100 is Stephen King, right? So you can take all the employees who have 100 as a manager ID. Those are all reporting to that guy called Stephen King. So you can see Nina, Lex, they are all reporting to Stephen King. Let's see that. Nina, Lex, Nina. You can see these people are reporting to Stephen. They are not only reporting to Stephen. There are a lot of other people. These people are all reporting to Stephen only. Because Stephen is the top level management. He is the head of the company. But Nancy is reporting to Nina. Right? Alexander is reporting to Lex. Like this, you can able to find the data. But as I told it, self-join is not so simple. It is a bit complicated. We have to connect within the same table. With me, Sugma? And in addition to that, if you have a salary in this table, yes, you can put one more condition.
Yeah.
One more condition. Where? And
E dot employee ID greater than E dot employee manager ID. Sorry, salary.
The employee dot salary.
Salary. Greater
is
than
greater than the employee dot
M dot.
the manager table dot salary. So it will show you who are all getting the salary more than his manager. More than his manager. Or who are all getting less than his manager. Whichever. Right? This is additional condition that we have to add in addition. There's no people. So this is the one. Like E1 is nothing but the table which you are considering as a, like a manager table, right? Who are all the manager salary that is less than the employee salary? This E is an employee. This E1 is the manager table. So employees who are all getting lesser salary than, or managers who are all getting the lesser salary than employees. If I try to find, no data is there like that. Everybody are getting higher salary than the employees only. It seems to be. So you see here, he is the higher salary, then next people, then these reportees and all are getting lower salary. Maybe equal salary, we'll see. I'm not sure whether we have the data like that, but we can update the data and see in that way. If you update, we can see the data. With me, Sugma?
Yes, Irfan. Yeah.
That's a great thing. So, team, what I'm trying to show you here is not the complete interview related question here, but that one we will discuss once again. This question, this particular things and all, we will again discuss. I'm just trying to make you understand what is self-join in general. Try to only just understand that self-join means what in general. Try to understand the concept here. But applying all this scenario and all is not a simple thing. It is a bit tricky thing. We have to think in a bit different way. Like with this given time, we can't think about all those. But subsequently, we'll again go and learn SQL only, but maybe in a different name, in the name of BigQuery, in the name of Synapse, or in the name of Spark SQL, like this we learn. At the time also, again, we take this, but not in this angle. We'll talk it in a different angle. Then we go with the interview related question discussion. That is a different story. There I'll not go and show the concept, like how the concept I'm covering here, right? It's not the way we are going to see. We are going to see the scenario based for something like this. Something like this we are going to discuss there. So you can see this is one set of interview question we discuss. But I want to give some scenarios also to you guys on this aspect. Then we will go and discuss on this question. Like not now. I want to give first of all some quiz and other things and all related to the basic concept first. These are all some extended concepts. We are going to discuss on this with the basic level and advanced level. Maybe we'll try to cover some of them today, but not all of them we can cover. Okay. But we will see this one, which is going to be a scenario based. There, first we understand the base, then we go with the scenario base, you can understand. So now we have a requirement of going with group by, right? So find the average salary of employees in each department. So it's a pretty direct thing, right? But it requires maybe a join or may not be a join. It depends. I want to just get the department information also. Department name wise, if I put here. Find the average salary of employees in each department with the department name provided. Name displayed in the output. Then for what I had to do, I had to go and calculate the average salary of the employees. So how do I do? Select average salary, comma, department ID from this employees table, right? Group by department ID. This is how I have to write a scenario. See, basically, there are some core concepts in the group by. I'm just talking in that, like a basic level, okay? Just consider this as a very core level I'm talking about. What is the requirement that we have here? So I wanted to know about what is the average salary in every department people are getting. That's my requirement. So I have 10 departments. One department, I may have multiple salaries offering. But what is the average? I add all the salaries and I will go and divide the number of times that salary occurs, right? So the average salary is nothing but sum of salary divided by what? Count of the number of records present. If I calculate like this is nothing but the average of salary that I can get. This is the average salary. So if I go with even average salary here, almost it will return the same, right? Am I getting the same result, guys? But what it is doing, it is consolidating the data based on the department ID. But my ask is what? My ask is, show me the department name also. Don't show me only the average salary of every department. Show me the average, the department information also. So I will go and join with what table? Department table also. So if I run like this, it will throw an error of saying, Irfan, first of all, the join condition I use strongly, that is fine. It will say there is a column ambiguity is there. The department ID field is present in both tables. So mention which department ID you want to bring. Okay, employees department ID. In the group by also you mention it will say. Okay, group by it is taking what department ID I have given here. That is fine. Now I don't need only the department ID wise average salary. I wanted the department name also. So I give D dot department name. If I give like this, will it work or not, Tim? I'm going to say calculate the average salary department ID wise, department name wise. Department ID and name are going to be same only. 90 means some department, 80 means some other department. But there is a thumb rule in the group by query that when I write, aggregation query when I write. What is the thumb rule? Anybody aware of that? So okay, it won't work as per Sukumar. How it will work then? If I want to make this work, what I have to do? A thumb rule I have in grouping the data. What is that?
So we have to add a department name in group by.
Yeah, basically the concept is what are all the columns that we are using additionally in addition to the aggregate function in a SQL query. In the select statement, we have to bring all those columns in the group by column also. Otherwise, it won't work. Otherwise, it won't work. This is one of the thumb rules. So basically, I have some data in my table, in my file. Department ID, salary. Department ID 1 contains salary of 10,000, 20,000. And department name also I have. Let's assume like this. Now, I wanted to aggregate this data. I want to calculate the sum of the salary. Right? Sum of this amount I want to calculate. Where is that aggregate function? Aggregate function I'm applying. If I give like this, right? We have to go and copy this and put here to make the people understand, right? This is the sum of the data. Should I have to put like this? For this department ID, department name, this is the sum of amount, right? This is how I display the output, right? So what are all the columns that I'm using in the select to produce the output? I'll parallelly get that columns in the group by column, whatever I'm using, I have to display that in the select and as well in the group by. Okay, that is the thumb rule what we have basically. So these columns I'm using additionally with the aggregate function column. That column has to be present in the group by for sure, otherwise things will not work. Otherwise it will lead to a wrong result. I mean, otherwise it will lead to a failure. Okay, now I'm going to change the order of this group by. Will it work? It works. It works. But is the order matters in this case? Order matters in this case. If I change the order, will it result differently? It won't result differently in this case. In this case, the same result only I'm going to find, because the department ID and department name are having the same hierarchy. The ID and name I'm displaying. But if I'm going to add one more column, rather than department ID, I'm going with location ID. Department dot, employee dot salary, comma, department dot, employee dot department ID, department dot location ID if I add. As one more column, I want to know department wise, location wise, what is the average of salary? Or location wise, department wise, what is the average of salary? Anything it can be. We have to know about which has to come as a super data and which has to come as a sub data set. Under a location, we have multiple departments, or the department can spread across multiple locations. That we have to understand. That we have to know. So here I'm going with the same order what I'm selecting in the select also, that is fine. If I run a query like this, will it produce some result, right? It produce some result. This is the result what it is producing. If I change this order, will the result vary? First of all, will it run? And will the result vary? Location first, department second, when I mentioned. Does the numbers varies, or it will still show the same number? Team. No idea? Result vary. Because you see here, in the department, in the location ID of 1700, we have department 90, department 100, department 30, department 50. So department spread across, or one location have multiple departments. One location, multiple departments are there. But if I go with the department ID, location ID first and department ID next, the result may vary. The result may vary, depends upon the data what we have, right? So here there is no variation in the data. If I add some data set, it can be varied. Something like this, you can see what I'm trying to convey. I don't have a department ID, location ID I have. Let's consider location ID 10, 10, 20. In a location of 10 and 20, the department 1 is spread across. And in the location of 20, the department ID 2 is spread across. Let's assume this is how we have the data. So now we are going to perform a, aggregation operation. Like I'm going to say location wise, department ID wise, sum of salary I'm going to calculate. So I'm taking this location with a combination of department. This is the maximum combination what we can have, right? So it will result in 30,000 here. And rest of the data will be displayed as it is. This is how the output will come. Are you able to aggregate this one? Do you agree this? This is how if I have the data. Okay, now I'm going to change the grouping order. I'm going to say don't group the data first by location. First you group the data by department. Then you group the data by location, like this when I say. So how it will change? For location ID 1, for location ID, for department ID 1, we have 2 locations, 10 and then 20 separately. Then for this one, you can maybe like I will put something like this, right? Rather like this, I'll put. This one is also coming in the same result, right? 220, 330. Maybe I'll put one more value. Okay, so here plus location ID of 30. Okay, let us have something like this. Now I'm going with department ID and the location ID inside that, right? So department ID 1 with 10 and 20 is there. Department ID 1 with 30 is there. I'm just trying to simulate the data, but let me try. One, 10, 20, 30, 20, 30. It is coming with the same result, right? It is coming with the same result. With this data, what we have. How I can bring the data? I'm just thinking about it. Okay. Maybe this one is bringing the same data to us, right? Because of we have the two values over here. If I'm going to make a modification like this in the other hand, right? This one is returning me the same data. If I change the order, but basically, if I change the order, right, depends upon how the data is scattered here and there, we can able to see the different result also at times. But in this case, like I don't have the data to simulate here, but however, I can ask you this one. This one will be resulting in a different result, right? If I use a location over here, I got a result differently. But if I don't use the location at all here, right? It is resulting with the result like this. Along with the location also it is resulting. But if I use only location here rather than department ID, rather than aggregating the data with the location ID, I'm going with the department ID, I'm going with the location ID. This one will be changing. The data that we are using in the group by column that we modify, right? It will change the result. Can I use department ID here as a, like a group by column? I used location ID as a select, but I'm giving the group by department ID. Will it work, guys? It will expect the same column as per the select expression. So what it is telling, the select list is not in the group by class. It won't work. Okay, if I don't have a, like a kind of an column used in the select, but I wanted to group by based on some other column. Will this work? I'm not displaying that output or which column I'm in the screen. What it is producing? It is not producing the output in the screen, but it works. This is a misunderstanding what people ask. It won't work. The reverse will not work. If I give select column with the department ID column, but group by I'm not giving, it won't work. This won't work. It will expect all the select column in the group by. In addition to whatever the aggregate column that I'm using, all the select columns has to be in the group by. This won't work. But the reverse will work. The group by we can have with this column, but what is the meaning of doing this? It won't give you a big meaning, right? Which department ID have this salary, I don't know. But it works actually. The thumb rule is what? Basic thumb rule is what? Whatever the column that we are using in the select in addition to the aggregate column should be in the group by. Otherwise, it won't work. But reverse is possible, but we don't use that very regularly. With me, team, in this, right? So basically, the group by basic concept we have to understand. Leave this joins and all. I'm doing with the direct department ID based group by operation, right? Department ID wise group by operation I'm performing. Whatever the column that we are using in addition to the aggregate column in the select, that has to be in the group by is the first thumb rule. Second thumb rule is like I can have any number of aggregation values in a given select statement, right? We don't require, these columns and all supposed to be added in the group by. We have to only add the normal column, not an aggregated column. Any number of aggregation we can do. Any operations we can do with this aggregation. It works, everything works. But the only thumb rule is we have to get the column in the select has to be added in the group by. That is the only thumb rule. Or we are not having the column added in the select, but we are using in the group by. What is happening? It is working. It works. Okay, can I remove this group by? If I use a aggregation function in the select, should I have to have group by always? Will this work or not work? It works. What it says, Irfan, I'm going to totally calculate, not based on department or anything. I'm going to totally calculate what is the average sales of the average salary of the employees and sum of the salary of the employees that I'm offering. So there are a couple of thumb rules are there. You practice, you can subsequently get that, right? So find the departments having, okay, what we are into here, right? Maybe if I go with join, then I have to add the join condition also. Let it be. I don't want to display the ID. I want to display the name. So I'm joining and then aggregating. Join and aggregation, we have to consider this. Okay, let's go with some more classes like having class. See, basically in the SQL query, we have to have an understanding of these classes, guys, for sure. Select, from, where, group by, having, order by, limit. This everybody has to know. Agree, team? But each and everything has an nitty-gritty. If I ask hundreds of questions in this, I wanted to get an answer from you. Maybe let me complete this having and order by and limit and all, and then I'll go with enormous number of questions you answer me. In this itself, you can answer a lot of questions. Okay, some hidden questions I'm telling. Not everybody are aware of. Let me ask you those questions, okay? What is having, guys? It's a very important interview related question also, right? What is the difference between where and having class? You guys got this interview question, couple of you guys in SQL. Pretty interesting interview question, right? What is the difference between where class and having class? You got this question, guys, anybody? No? No one have got this question? Okay, answer me this question. What is the difference between where class and having class? In general, I'm going to apply a filter like this, select star from employees, where like department ID is equal to 80 or 90. Show me all the employees who are belonging to the department ID 90. I want to know that. You are with me in this query, team, all of you. Show me all the employees who are all belonging to a department 90. This is my query, basic query. Now, show me the employees who are all getting the salary greater than 15,000 or 14,000. 14,000, who are all getting the salary more than maybe 10,000. This you are understanding very clearly. I want to know, show me the employee IDs. Employee IDs are show me the, like maybe the name of the employees or the departments of the employees or designations of the employees who are all getting the sum of salary greater than 8,000. How can I write the query here, guys? I want to know which are all the job ID where, or which are all the departments. I can put like this, right? Department ID, where the sum of salary of the department is greater than 20,000. In a department, I'm giving more than 20,000 of salary to the employees. How can I write a query here in general? I want to know, show me the departments whose sum of salary is greater than 20,000. So can I write where sum of salary is greater than 20,000 like this in general? It will throw an error. Sorry, Irfan. You can't able to run a query where the having class could not support the group by function. You have to use first thing. Let me use that. You can use the group by function for sure. That is first of all suggesting group by department ID. But we can't use aggregate functions in the where class. This is one of the thumb rule that we can't follow in SQL statements. For this, what we have to do? We have to go with post group by, because what is happening here is the data will be taken and aggregated like this. Post group by, I have to use, rather than where class, I have to use a having class of sum of salary greater than 20,000. So you are able to understand, like the order in which the SQL I write is select from where, then group by, then having. Having is also a filter function only. Having is also like where. The small difference between where and having is where will be used for a normal columns. Having will be used for the aggregated function columns. If I use aggregate functions and I want to apply some filter on the aggregated data, then I have to use having class without any doubt. Okay, when I use having class, it is going to produce me the result great. Can I use where class also in addition to this? When I use having class, can I put a where class like saying where maybe like what is my employee table? Where the job ID is equal to IT programmer. Can I have an where class also added here? So this is the way how we go and write the SQL query. If I have aggregate function I use along with some other columns, I have to use group by. If I don't use other columns along with the aggregate functions, then I don't have to use group by. That is one rule what you have seen earlier. The second case is when I use aggregate function and I want to apply the filter based on the aggregate function that I used, then I can't use where class, I have to use a having class. Okay, when I use having class, can I use where class also? Yes. Where class has to come following the from. Having class has to come following the group by. These are all some of the core thumb rules that we have to know while writing SQL query. That's where I put select has to be known by everyone, we know. From has to be known by everyone, we know. Where has to be known by everyone, we know. Group by, we have to know, yes, we know. Group by means what? I'm going to say group the data based on the columns that I used in the select. If I use aggregation functions, along with some list of columns, I have to use all the list of columns in the group by. All the list of columns in the group by. Having has to come post the group by if I want to apply filter based on the aggregated column. We can say not order of execution, order of writing queries. Order of execution is different. That is where I wanted you guys to go and refer this foundation document that I have created. Though the query you write in one way, how you write the query in one way, Soundar, the execution will be done in a different way. You can see it will take the data from all the table, either directly or by joining, then apply the filter, then apply the group by, then apply the having, then apply the select and produce the result to you. Then apply the order by and then apply the limit. Last week I talked about in BigQuery, when I'm going to write a limit even in my query, it is not saving the cost. Why? This is the reason behind. This is the reason behind. The limit will be applied in the last, after all the data is brought to your computation engine, and after do all the computation, the final limit will be applied to restrict the data that is going to produce in the output screen. This is one of the very important interview question, right? In BigQuery, I'm just telling as an example. The limit function, when I apply even, it won't save the cost. Most of the people think like I'm limiting and getting 20 records, 100 records. Why they are charging me fully? This is how the architecture works in the SQL query. So we have to know that architecture. Okay, let it be. Group by, after that we have to use having. This is the order in which you have to write the query. We don't have an option. This is the one I wanted you to understand fundamentally, right? All of you. Select from where, group by, having, then you can use order by. Order by department ID, or order by sum of salary. You can say order by 2, the second column. Order by second column. Yeah, take care, everybody. Order by first column. You don't have to write that again, that values and all. You can give some number. Limit of only display 1 record, 2 records, 100 records. This is a very, very important SQL query that all we have to first know. Then only the joins and all. Okay, I need the people who are all not from the SQL background. Whether you understood, I can select the data from a table by mentioning the columns, by applying some aggregation functions. Right? I can only select the columns, or I can only do the aggregation functions. This you are all aware of, team. Forget about all this. I can do either this or that. Select sum of salary. I can run, it works. It works. It calculates the total sum of salary of the employees table. Or I can say select department ID. It also works. But if I marry these two, and run, then it won't work. If I use a normal column and an aggregated column, summary column, it won't work. Then what is needed here to add? What is needed here to add, guys? I have to add group by. Group by. Here comes the purpose of group by. So now what it will do? Department ID wise sum of salary, it is displaying. Grouping the data based on the first column. I can use the number here even. For group by and order by, we can use the number of the column number. This is column number 1, this is column number 2. I can mention the column number also, or I can mention the actual column also. Everything works. Now I want to apply some filter on this summed data. I want to say, hey, whichever the sum of salary that is greater than 45,000 alone you display, or 25,000 alone you display. I don't want to see this data and all. Whichever is greater than 25,000 rupees, whatever I'm depositing I'm spending for my department. Whichever the department I'm spending higher amount. So then we can say having sum of salary greater than 25,000. We're able to see like how we are forming a query one after another. Very, very important part of our learning. Then I'm going with where class also. I'm going to say where only for the job ID of IT programmer, or only for the job ID in IT programmer and who are all belonging to the department, IT programmers and who are all belonging in the an accounts department. These two departments I want to identify in my company. This is applicable only for these two set of departments. I can add a where clause. After identifying all this, I want to sort the data based on the sum of salary in a descending order. So order by column number 2, that is nothing but this column, in a descending order. So it will sort the data and display the descending order of sorting. Then I want to see limit only one record. If I have to write this as a description, like an interview question, if I want to ask this one, how do I ask? Hey, I want to see the, like a top salary consuming department. Which department is consuming the top salary? Or which department I'm giving a top salary out of the employees who are all working with the job ID of IT programmers and accounts employment, who are all working as a job ID with IT programmers and like accountants. Only those accountant people and the IT developers alone, those departments alone, I want to know what is the total sum of salary. That too, the top salary department alone, I want to know where the salary, the sum of salary greater than 25,000 alone. So in this, if I don't have greater than 25,000, I'm not bothering. But if this the job ID working people belonging to a department where I'm giving the salary more than 25,000, I want to see the top one department and the equivalent sum of salary of that. Like this, if somebody asks, I have to write an entire query like this. Since we wrote the query, we can able to answer what is the question. But if the question is asked, answering that question by writing a query is a bit tricky thing. For that, we have to understand each and every of these parts separately. With me, team? Here, there are a lot of questions may come, lot of confusion may come, but this is a very basic concept we have to know for sure. So that's what I asked you to go through this one and understand. In the DQL, the way how do we write a query and how it executes in the behind. Executes how it in the behind, you forget, don't worry. But how you write the query, what is the order in which the sequence of program we have to write, the query we have to write. Only these are all the major classes in SQL. We call it as classes, right? Classes. What are the SQL classes? Select, from, where, group by, having, order by, limit. These are all major important SQL classes for a fundamental learners. Can we use department ID in the where class? Anything we can use in the where class. Anything you use in the where class. Other than what? Other than aggregate functions, right? Other than aggregate functions, we can use anything. So there is a function called, there is a filter condition called between and is there. Whether I covered that? Are you aware of this function called between and guys? Let me put one more where class, right? Select star from employees where department ID between 10 and 100. What does it mean, guys? You are all able to understand this query in general, what I'm mentioning? What, this is equivalent to what? Rather than I write like this, I can write it in one another way. Can you suggest me what other way I can run? Range, great, range. But this includes 100 also. It includes 10 also. 10, 11, 12, 13, it will put up to 100 and help me get the result. Rather like this, I can put in what other way? The same query I can write in one another way. What is it? Where department ID greater than or equal to, greater than or equal to 10 and department ID less than or equal to 100. By this way also I can write. Both are correct. This way I can write or this way I can write. So people prefer which way to write? This way. 100 and 100 is equal to 10. 100 and 100 is equal to 10. 100 and 100 is equal to 100. 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 1 You can write job ID and department ID, or job ID or department ID. I don't bother. I don't bother. Like a filter condition. This is like a filter. This is like a if condition in Python. This is like an if condition in Python. Right? This is like a print statement in Python. We do aggregations in Python soon. Python means PySpark we do. Having like these kind of functionalities, PySpark have brought in the name of SQL queries or data frame. So you can go and simply write a PySpark program with the same SQL query what you are learning here. So if you are getting familiarity in SQL, right? If you get a familiarity in SQL, working in Python is not working in PySpark is not a big deal from next week. PySpark program I'm creating. Right? Okay, I don't have PySpark configured in this system. Okay, in the other laptop I have configured. That is okay. Let it be. So we can go and write the same queries in PySpark. It works, literally works. Okay, so this practice is more important for even working in PySpark. That's where SQL is playing a very vital role. Okay, fine team. You are all with me in this team. Now I will go with some questions on this. There are some nitty-gritty questions we have to know and understand. Okay, so let us go on this itself, right? The first question is, what are all like are the like you can consider with this itself couple of things. This one query represents, first of all possible classes, the regular classes, general classes used in SQL. First thing, this query shows the order of writing entire SQL. Okay, these are all some of the points I want to first bring. Now, let me ask you this question. If I write a query like this, will it work? I wanted especially the people from non-SQL background answer this. Will this work? Right? It won't work. Then how I can make this work? I have to add group by the first column. The non-aggregate column, I have to group by. If I give the second column, will it work? Group by 1 I am giving. If I give group by 2, what's the meaning of doing that? It won't work. Can't group on sum of salary. So you have to give group by 1 only. Okay, one more question. If I remove this sum of salary, will this query works? Will this query works, guys? It works. It works. It works. How it works? What is the meaning of doing this? Any idea? This is one of the very important interview question even. Not a direct interview question. It's an indirect interview question. They don't ask whether if I have a group by class used in my query, I need to have an aggregate function or not. That is not the query I may ask. I'm telling, always we use group by in what case, guys? If I use some aggregate function. I say what? Since I'm using aggregate function, I have to group by with this column. That's what we say, right? In general. That's how the common assumption what everybody has. Agree? But the problem here is, right? We don't use the group by only for that purpose. We can use the group by to say, hey, I want to group the data based on department. I want to calculate the sum of department while I'm grouping. So something like this. The group by is all about something like this, right? Something like this. If I have all these departments, I want to group the data based on department. What I do, I go and maintain only one time, two, then three. Like this I maintain. So if I go and produce the data, then I'll do what? I can't keep all this salary as an individual value. So I will do what? I'll do something like a sum or average or min, max, something I do, and make this three salary as one. Either average I calculate or sum I calculate, min calculate, max, standard deviation, something I calculate, mean, mode, variance, something I calculate. In this one, how can I fit this salary? That is where we do aggregation. For aggregation, we are doing grouping. For grouping, for grouped data, we have to do aggregation. But without aggregation also, we can have only the grouping done. That is the core concept here. So why I have to do a grouping? So if I have the data like this, departments like this, why I have to group and get only the department alone without doing the summation? In what situation I may do this? By doing this, what is happening? What is the outcome I'm producing? I'm removing what? Duplicates. I'm getting the unique data set. I'm doing deduplication. This is a very big scenario, what we get. We can go and say group by this particular column. So it will return only the deduplicated data. Or rather than writing group by, I have one more option to achieve the deduplicated result. How? By using distinct. In some databases, not all databases, rather than using distinct function, use group by function, which will be more efficient for deduplicating data. But we can achieve deduplication by using multiple methodologies. So to deduplicate the data, we can use even group by without aggregate function. It works. Okay, just let me put it for your reference here. You can go and refer this here. Okay, team. Group by has lot of meaningful thing. Having now you got guys an idea. You guys got an idea. When do you use having? If I want to filter the data based on the aggregated column, then I use having. If I want to do a normal filter, I don't use having. Count function, one of the important function to understand. Count function. Okay. So count is also an aggregate function. I want to know department wise how many number of employees are there. Department ID comma count of number of employees as employee count. I'm using an alias. Group by 1. This is a common program that we are running. It's a common query. We are all aware of. Okay, now my question is, rather than putting count of star, if I put count of 1, that is going to improve my performance, I'm telling here. Okay, I'm just telling. If I put count of 1, the performance will be improved. So people used to follow a way of writing a query like, rather than count of star, they put count of 1. Any idea for this team? It works even. It will return the same result. The same result I can get. But what's the difference between using count of star and count of 1? Any idea? Okay, that is a very important concept you guys all have to know. Okay. The count of 1 will select what? As Sendil said, the first column. Not the case. Not the case. It won't select first column. It won't select first column. Okay. What it will do for when I do, let me just show you this one, right? Rather, select department ID or leave the department ID, or I'm selecting the department ID, let it be, comma, I'm not selecting count of one, I'm selecting just one as, like employee count, something like this I'm selecting. What it will show the result to me? What it will display? The department ID, and along with it, it will put number one. It will just put a literal number one along with every department ID. Are you finding that? 31 rows are returned. All the 31 rows show just one along with the department ID. If I put rather than one, if I put star here, what it will return? It will return all the rows. Agree? All the rows. Now, returning all the rows and counting the number of rows is more faster, or just putting for every row one and counting that one is more faster? Tell me, team. Counting the one is faster. Agree, right? Why you are asking it as a question, Shiva? That's a literal thing, right? I have 10 rows of items in front of me. Counting the 10 rows of item is better, or just putting 1, 1, 1, 1 for every item and then count that one is more better? Counting the one is more better than counting the 10 rows, right? So that's where we use count of one in general in the database to improve the performance. Okay. So I'm going to count. Select count of null as our friend is telling. The null is counted as 0 as our friend was telling. So if I have a null row in my table, one of our team member have told a great, input, right? She brought a good point here. When I'm just selecting star from the table, how many rows we have? How many rows we have overall? How many records we have in this table? 2 records. Agree, 2 records are there. Now I'm going to say select count of star. Though it is a null record, it is returning what? Her count of ID. Count of ID. What it is returning? The record wise, when I count, it will return the record as a record is there, but value is not there in that record. That is a different story. But if I choose the ID column, how much it is returning, what it is returning as, who told that point? Aishwarya. Right? This is a very interesting thing. But if I rather than put count of ID, I put count of 1. The 1 will be displayed how many times in general when I write a query on top of this table? The 1 will be displayed how many times? It will be displayed 2 times, regardless whether I have a null record or a normal record. So when I do count of 1, it returns the actual number of records in a table, regardless whether the record is having nulls or not. The column has a nulls or not. So when we use the count, we must be cautiously using it. The count of ID is different from count of 1 or count of star. So you use count of star or count of 1 if you want to get the record, the total number of rows in the table. Total number of rows in the table. So let me mention that, right? Use count of 1 for better performance, or at least count of star for counting total number of rows in a table regardless of null or not null rows. If we use count of a particular column, the null values will not be counted. This is a very, very important rule that we have to consider. So select count of 1 from employees is good, or select count of star from employees is good, or employees is going to return me, return all rows, all count, all rows count. This will also returns all row counts. But whereas count of ID, if I mention employee ID or department ID, if I mention, if I have a null department ID, right, then returns only count of not null department ID values. Are you all with me in this team? This is a very important factor to consider. Let me add one more point here. One more very important point here. Maybe I may be covering that in the subsequent queries, but I'll just add this one more point. I wanted to still count the data from this table which has null by using count of that ID. So count of ID I'm just using here. It is returning only one as a count because one ID is null, one ID is value, having a value. Nulls as what? Values. How can I do that? I want to still use the count of ID. It should return 2 as a result. If the ID is having null, I wanted to convert that into some meaningful value. How can I do that? There is a function called, a very interesting function, very important function. It will not be considering it as a null. It will convert that null to a meaningful value. How? By using a function called coalesce. Coalesce is a very, very important function we use, where the coalesce will convert the null into some meaningful value. Whatever the value that you give, it will convert. So if I use count of coalesce of ID comma 1, then how many records it will return to me? 2 records. So you have to use, along with coalesce, if you are going to access the ID or some column, which you may anticipate nulls may be there. If you wanted to include the nulls in the count or exclude the nulls in the count, you have to use it appropriately. So if you want to include the nulls, the point I'm adding here, one additional point. See, I'm not telling wrong about we should not, the null should not be included. I'm not telling wrong about it. Something is happening, guys. 1 second. Don't know, my shift key seems to be pressed. Oh, my control seems to be pressed automatically. Okay, fine. So return a not null department ID count alone, but I want to return the, like I want to count even null department ID also. Return the count of null department ID values also. Like this, if I want to do, I have to explicitly go with the function called coalesce. Collage will do what? Convert this null value to some meaningful value that you give. Do you remember there is a collage kind of function we learned in Python by any chance? I was talking about that is a very important function to use. Remember, team? In Python, we learned that function. What is that function? Okay, default is fine in dictionary. And one more function in dictionary, get function. Yeah, great. So I'm having a dictionary of items. I'm going to pass some key as an argument. 5 is the key I'm passing. It will return what? Null. Sorry, Irfan. There is no key called 5 is present in your data. Then I'm going to say what? No. If you don't get result, make it as 1. Return me at least as some number called 100. Default number 100. This is collage. You are with me? Collage. I'm going to say, hey, collage, can you go and search for some value called, some key called 5 is present in this dictionary or not? If the 5 is not present, you return none, right? Rather than none, you return some number. I can go and do some operations on that number further, count operations on that number further. Can you relate this, team, or not? The get seems to be like a collage. If the get function returns none, you return some value rather. Don't return none. I don't want to see none. Can you relate that with collage, team? Are you able to relate that with collage? Collage is a very, very important function. Everybody should know. We'll use this very heavily in a later point of time. There are a lot of other related function to collage, but leave that. Collage alone, let's consider. Very, very interesting function. Okay, very, very important function as well to be used. Okay, fine. Sum function, min-max function, these are all some functions you will be using very regularly, right? Multiple aggregations that we can do. So we can do count, max, min, average, everything we can write in a query, right? This one we can run always. So how do you do a, like a proper indentation of the query? This is how we write. Select the columns. If the column is pretty direct, you can give like this. If it is going to be like more function based or a lot of functionalities, if we have, keep the columns like this. This is how we do the indentation in the queries. Select the columns, then from class with the table, then group by class or whatever we write. We can do multiple level aggregation. So what we do, we give an alias, count, AVG salary, max sal. Like this, we can give a query in a proper shape, like this. Okay, for your reference. Join with alias. This one we have already seen. Let it be. I can go with an alias name and I can go with a join. Maybe I can put it there. Yeah, already we had, right? Maybe I'm giving it in the bottom. Let it be. So what we have seen is joins and aggregations we have seen. You are all good in the aggregation, guys. Join, however, we use. Aggregation also we heavily use in a later point of time. All I need is what from you? Know the syntax. Semantics, however, we again iterate multiple times. Couple of people when they speak with me in the personal connect, they were telling, Irfan, SQL, I found some challenge in getting some scenario achieved. That we have to get ready by doing a lot of iteration. I'll make you guys do that. As I told it, we are creating some environments. Using that environment, you guys are going to get a lot of those kind of scenarios achieved. So wait for it. We'll soon release those kind of environments. Okay. So wait for it. I'm just building such kind of engines also for you guys to help you. Okay. But for now, what you can consider, right? With these given things, whatever we covered so far, I'll give you some scenarios soon. Okay. By this week, I'll be sending you some scenarios. Get practice to that. Try to spend some time on putting the data in some table, in some Excel sheet first. Then you apply the strategy there. But before that, you have to get familiar on the, the syntaxes and semantics. That only get familiarity. Okay. Okay, team. So next one is some concept called subquery. We go with some concept called subqueries. What is subquery, guys? Okay. So certain other questions I may ask you, I told here, right? Further on this SQL query itself, I'm going to ask you a lot of questions, which you may not be completely aware of. One example is that one I used here. The difference between count of or star or one from the table. In general, any query that we are going to write, first of all, any query that we are going to write first, what you do? I want to check some functionality. I want to check whether this works or not. What I'll do, any functions I want to check, first I'll go and write it as a dummy select. Select police of null comma 1. When I write like this, it will show me what will be the return result. Okay. If you wanted to run it on a table, you can run as well. You can run on a table also. As an example, you can create one sample table and try also. So always to practice a query, you run it as a dummy query without a table or with a table also. That is how we can get practice on a query in general. Okay, let me go with the concept of subqueries. But while we are learning the concept of subquery, let me ask you this question before that. Okay, I'm writing a query like this, right? Can I write a select with a select in it? Can I write a select statement with a select in it, or a select has to be followed with the from class only? Select some column from employees. Should I have to only write a query like this, or can I write a select statement inside a select statement? Will this work? Will this work, guys? What it is doing? I'm displaying all the count of the data for every job ID that we have available. So for every job ID, what is the total number of total employees that we have? I'm just displaying like this. My question is, can we write a select inside a select? Or in general, if I write a query inside a query, that is called subquery in general. Then I'll ask the question related to that. But in general, in a query, I'm going to write a subquery. We call it as what? The concept of subquery. So we have how many queries here, guys, in this line number 5? How many queries we have in this line number 5? 2 queries. We call this as, what are all the queries? What are the types of queries we return here? Main query and subquery. Can we call like this? Okay. We have returned in other name. There is a standard name people used to use for this. The name of this query is from class subquery, or any idea? We used to call it in a special name. Inline view. Inline view. We used to call this as inline view or from class subquery. Okay. What is subquery? First of all, you got an idea, guys. Nested subquery, when do we call? Yes, we can call it as a nested, but we go one more level down, and we create multiple nesting. If you do, we can call it as a nested query. But this is generally called as an inline view. Okay. Inline view. So an inline view is a SQL statement that embedded with the from class of the another select statement, right? So if you can't able to achieve a result of a query by writing from a direct table, we can go and have that result achieved first of all in the subquery, pass that subquery as a data for the another table. This is called inline view. In general, we used to call it as, but fine, that is okay. We'll use this more in detail later. But what is the application of this? We will see. But what can we write a query like this is the question here. Application we are going to see throughout our learning journey. Next and all. Are you with me in this team? What I'm speaking? Okay, just first try to understand what are all possible or not possible. So here without group by, we are getting grouped elements. Where? Here? You are talking about this one, Shanmunath? No, we are not getting.
In row number 3, Irfan. Yeah,
no, we are not getting grouped elements. See, without having even group by, this query works in general. When the group by will come, that is a very important factor, right, Shanmunathan? If I add some more column in this column list of the select, which is not aggregated, then I have to obviously use group by. You understood this, Shanmunathan? It's a very, very important point to consider. When do we use group by? If I don't have this additional regular column used other than aggregated column, if I don't use a regular column, group by is not needed. Group by can't be done here. If I give a group by, it won't work. It will throw an error. You are with me? Shanmunathan, you are
yes, yes. My question is, the result of the third line is group of employees in a particular job ID, right? That's what it's coming for. Each job ID, they are having 31 employees.
No. So the thing is, that is what the difference, right? Here, if I put just a count of star, it will be different. Every job ID, what is the count it will calculate? But this is something very tricky. This is calculating the total number of employees in this table, and it will display that count in the screen like this. So, see, basically what it will do, this query will run for every row. Every row, when the data is fetched from this employee table, 31 rows I have, this query will run 31 times in the beginning. Very costly. We should not use it very normally. We will use it very, very, like in a very critical situation or in a very, like a required situation. How many of you say, like, whoever knows some sort of SQL, have an idea about we can write a query in a select class itself like this? A subquery can be written in a select class. How many of you are not aware of that case? Because you might not have used this very regularly. Agree? I'm showing you here, there are possible ways we can write queries. Anybody agree that? Yes, Irfan. This way of writing query, I'm not aware of. Can you say like that? Particularly. The reason behind why I'm asking, because you don't use that so regularly. We don't use that so regularly. Most of the people not aware of this way it can work. But don't get confused on the aggregation and all. Like Shanmunath. You are getting me right what I'm saying? Don't get confused on the aggregation. So what this query will do, I'm yet to complete this query even. I'm just giving you an idea. In general, we can write a query in a select class, a subquery in a select class, subquery in a from class. This is a select class subquery. Select class subquery. This is a from class subquery, otherwise called as an inline view. This we heavily use. This we use it in different perspective, common table expression like this and all we use. That I'll talk in our subsequent days. But not everybody are familiar in common table expression. Even people working in SQL also not very much familiar. This is not correlated. There are different types of subqueries are there. This is not correlated. But Shanmunath, you are able to get the answer here. So what I'm doing here is,
yes,
I'm running this query for every row that I fetch from this employee table. Every job ID that I fetch from this employee table, it is going to run this query. The total count of the employee table, it will again and again count. Then the job ID also I'll fetch. I'll go and run the entire query on this table or not in this table. I'm going to run the query on department table. You are able to now understand?
Yes, I could get it. Okay.
So for every row that I fetch here, I'll run the query on the department table and I'm adding that result. This is not a meaningful outcome what you are getting today. Because
Correct.
if I go with the scenario, then it will be, it will be, you will be understanding. But I'm not talking about the scenario. I'm not talking about the business flow. I'm talking only about the possible way we can use the queries. When we got to go for a business with the scenario, we have to discuss. We have to take some topic. This is the requirement I have. How can I achieve that result? But before that, we are in a preliminary state of understanding. These are all the possible ways we can write queries. Agree? You are very clear?
Yeah.
So
Yeah,
take
got
it
it.
that way. So what I'm telling, we can write subqueries. Subquery means what? A query inside a query is called subquery. Right? That you guys are very, very clear. Query inside another query is a subquery. Subquery, there are a lot of concepts are there. I don't want you to worry on all the concepts, but giving you a first of all the option of saying what are all the different classes we can use subquery. Can we use subquery in select class? My first question. Tell me, team. Can we use subquery in select class? Yes, possible. Okay. Subquery in select class. Can we use subquery in from class? Possible, right? We can do subquery in some from class. Okay. Some queries may, some places it may work, some places it may not work with alias. I'll name it as a temp. Some name I'm giving for the data that I'm running here. I'll put it in a memory area. That memory area I'm calling it as a temp memory. From the temp memory, this from will run. So basically I'm telling what? Collect the data from the departments table, store it in a variable called temp, in a table name called temp, temporary table name called temp, and select star from, you run it on this temp table. Like this I'm telling. It will work in that way in the background. Okay. The next type of subquery what I'm going to give is, what's the next class that we can use, guys? Select from, then what's the next class? Where class. So select star from departments table or employees table. Where department ID, right? In the where class, I'm going to write where department ID of the employees table is not in, I'm going to write a subquery. Select distinct or select department ID from departments table. Is it a legitimate query? We mostly write this query. And this query is otherwise called as a single column subquery. This is a very, this is the real meaning of subquery. Whatever I did earlier and all, I'm just using subquery in different places. But the where class subquery is a actual subquery. It's a subquery in general. It's a subquery. We call the subquery by this way only. What is subquery? I'm writing a query inside. I mean, I'm waiting for a result from a subquery and I'm going to execute the main query. Here, how the execution will happen? First, the data will be collected from this table and loaded in the not in condition. All the department IDs will be loaded here. Then I'm going to run the main query to say what? Hey, what are all the department IDs are not belonging to this subtable query? You return me that one alone as a result. Like this, I'll be doing. So it is returning me this result. It is returning me the result of, hey, this is the only employee who don't have department assigned to him. This is the only employee who don't have a department in the department table. Like this, I'm getting the result, right? This is a very important query we have to consider. This is one of the interview question even. Show me the employees who don't have departments. We have seen the similar kind of question asked in somewhere else also. You remember? Joints also. Joints also. Great moment. Joints also we can achieve the same result. So there is a point here. If somebody asks you this question, what is the answer for this is, yes, I can achieve using subquery or join also. See, show me the employees who don't have departments. So we had to use what type of join? Left outer join. Right, Ravali? Why left outer join? all the data from employees I needed, whichever is not matching with the department I wanted. So department ID is null, I'll put. Not having department. So left side, I want to see all the data. Right side, whether it is matching or not matching, I want to see. So basically the department ID is not matching. But all the data from the left I want to display. So what I'll do, select E dot star from employees, E, left join with departments on E dot department ID is equal to D dot department ID. And where D dot department ID is null. When I write this query, it will literally return the same result. Is it returning the same result? So this is an interview question, regularly asked interview question. So we have to get familiar on either using subquery to achieve this or the join to achieve this. Slowly you will be getting into the state of working in an interview perspective, but I'm not interested in talking about the interview right now. We'll talk about it. First, we learn about the concept, right? Are you with me in this? Like a subquery, guys, treat it as an English. I'm telling whatever the data that is present in this table that is not present in the other table. What I do? I'm going to say I have two tables here, okay? I have a table 1, employee ID I have, department ID I have, like this. I'm having a department table where department ID is there, department name is there. Something like this I have. Now I'm going to ask, hey, can you show me the data from the employee table who don't have or where the department table does not have the department for these employees, who don't have department assigned, who don't have department assigned to them. Like this, I'm asking. So which are all the employees don't have department assigned to them? The wrong department assigned to them. This employee have department ID assigned, which is present. This department is also present, but the 3 is not present. So this is the odd man out, agree? This is the odd man out. How do I find this? Yeah, take care, Srinath. How to find this? First, I have to go and collect this department ID and store it in some temporary memory. Then I have to go and take this and compare. And I say, select all the data from this table, whichever is not present, whichever the department ID not present in this list. That is what I used not in condition. You are with me in this team? That's what I am doing here. Select the department ID from the departments table, all the department ID from the departments table, select the data from the employees table, where department ID not in the department ID of the other table. This is how you have to understand. That's what again and again I'm telling. The SQL will not come just like this. Either you have to put it in an Excel and relate and understand, or you have to imagine and understand. You have to store some data in one brain, one side of the brain. Okay, department contains 2 departments. Employee contains 3 departments, not in that department. So 10 and 20 is not present here. The balance I want to see. Or consider as a left outer join. Join the data using this department and department of both tables. You say all the data from employees I wanted, only matching the data from the departments I wanted. For unmatched data, you show as null. So which data it will show as null? This one, it will show as null. 3 is not matching here and there. So for rather than 3, it will put null here in the joined table. Then I'm telling on top of that, eliminate the null record. Or choose only the null record, I'm telling. Choose only the null record. Whichever the data that after joined, I found null in the department table, right? This is the department table's department ID. It will show 1 here, 2 here. Here it will show null because I used left outer join to show all the data from left. Deficient data in the right will be shown as null. For 1 also it shows 1. So I'm going to find this as an odd man out by using join. You are very clear on this thing? You are with me? With me, team, in this? Right? Right, team? So you have to, how you have to learn, I'm just trying to bring the point here. Okay? How to identify this? I'm just trying to bring as a point here. Okay. Let it be, guys. Okay, I can share you this. What other way we can write subqueries? This is a very, very important subquery to understand. We can create lot of scenario out of this. Lot of scenario out of this. Okay, we'll deal about it subsequently. Okay, this is a general subquery what we use in general. Now the question is, I want to compare a table with multiple columns. We call it as a multi-column subquery. Or we can call something called a correlated subquery. Somebody was bringing some point, right? So subquery is of different type. This is a single column subquery. There is some concept called multi-column subqueries there. But not everywhere the multi-column subquery works actually. Multi-column subquery represents what? I have 2 tables, let's assume. So I'm going to say what? Select all the data from employees table where employee ID is present in another employee table. Employees 2 table, like this I'm asking. This is a normal subquery that I'm writing. Whatever the data present in this table, I want to see the same data in this table also. Right? Whichever the data is not present in that other table, don't show me that. This is equal to what? Inner join. Agree? Inner join. We can relate this with inner join. But let it be. We'll talk about the joins and subquery relationship and all later. Very, very important point to know. These are all we are going to learn in our subsequent days. In the name of Spark, we learn. In the name of BigQuery, we learn. But not in the name of, like MySQL, we learn. MySQL is for basic understanding. Okay. Now, I can add more than one column here, employee ID and department ID. I want to choose, I want to see whether these both columns are matching here. So, not every databases work with this, but let me check whether this work or not. Like what I say, hey, 2 columns I want to compare with these 2 columns output. Employee ID should match with employee ID, department ID return should match with department ID. This is called multi-column subquery. This query is working here in our, MySQL. Okay, let me go and try the same query in BigQuery maybe. BigQuery. The same query I'm trying to write in BigQuery. Just I'm writing a normal query here first of all. To say take some columns, okay, just for a reference. Account ID, account type. So select start from this table where account ID, comma, account type in of select account ID, comma, account type from this table. When I write like this, in BigQuery I'm talking about. BigQuery is also like a SQL platform only. I'm just giving you an idea here. Is it working? Is it working? What it is telling, guys? It only works with single column subquery. Multi-column subquery won't work. But MySQL works. It doesn't mean that MySQL is better than BigQuery. It's not like that. MySQL directly supports this. BigQuery does not support this because of column-oriented database and all. Lot of reason behind it. Forget about that reason. But I want to put some intelligence here to make this query work in BigQuery also. In MySQL, it pretty directly works. I want to match it 2 columns to identify the output of this table. These 2 columns should match to provide the output of this table. How can I think ahead and make this query works in BigQuery? Multi-column subquery won't work in BigQuery directly as like MySQL. But I still wanted to make this query work. How can I do this? How can I achieve this? Tell me, team. Any idea? It's throwing an error, right? What it is telling? Only one column can be used in a subquery in MySQL. We can't use multi-columns. Multi-column subquery is not supported in MySQL, in BigQuery. Other than that, most of the things work in BigQuery. Same query works here also. But this won't work means what we have to do? Great. Great answer, Sounder. Join will help you achieve the same. So rather doing like this, what you do? Achieve the same query by using join. That's a great answer. Agree. A, same. I'm going to write A, inner join with the same table B on A dot account ID is equal to B dot account ID and A dot account type is equal to B dot account type. By this way, what I can do, I can achieve the same result what I expect. From the A table, I want to know the result, whichever is matching with the B table account ID and the account type. Great, I got the result. It works. Great answer from Sounder. Right? You can see here. It is giving me the result as I expected. But in the other hand, I still wanted to use not join. I want to still get the result. That is the question what I have. I still wanted to make this work. How can I make this work? How can I make this work? What we can do, we can go and concat this 2 columns and make it as what? What it is telling, you have to give me 1 column. I can't go with multiple columns to run the subquery. Right? It seems to be a big table, so it is taking longer time. Since I don't have index or partitions, clustering and all done, let it be. So now you see this query, it will work. This works. I can combine the column and make it a single column. So single column subquery works, right? Let it work. This is how the thinking you have to make bit ahead of what I'm telling about, right? So here it is directly giving me the result as I expected. That I had to do some workaround. Okay, tip. What is multi-column subquery? You are all with me in this team. Are you with me in this? Single column subquery, multi-column subquery. From class subquery, select class subquery, where class subquery. Lot of things we have seen. Can we write subquery in where class? Is the question. Yes, we can write. We can go with 1 column or multiple column. It works. In some cases, it works. Some databases, it won't work. We have to put some workaround for that. There is something like correlated subquery. One type of subquery. What is correlated subquery? The way how it works is a bit costly. We'll talk about it later. But what is correlated? I wanted to say, hey, when the parent table, this is a parent query, this is a child table, let's assume. This is a child table, this is a parent table. what I'm going to say, I'm going to run a query like this where exists one of the pretty interesting function. And very, like not so easy to understand what I'm going to speak also, but take it lightly. I'm going to say, hey, select some data from the inner table, the child table, whichever is matching with the employee ID and the department ID from the parent table. So I'm going to run a query like this, where I'm not running a join, I'm doing a correlated subquery here. What is correlated subquery? The parent table will fetch one record, one employee ID and one department ID, one department ID and one employee ID it will fetch. How this will run, I'll tell you. The parent query, right? The parent will fetch this data from the database, like 100, 90. 100 is the employee ID, 90 is the department ID. And what it will do, it will send that query to the child table. The parent dot, it's not like that actually. What Gokula you are telling is not the only case. It is a kind of a, like a multi-directional query. It's a multi-directional query. It's not a single directional query. As you mentioned, main query runs first, then the child query runs second. It is a like a directional query. We wait for a while. I'll talk about it, right? Very, very, like a challenging query. And child dot department ID is equal to parent dot department ID. Like this, I'm having this query executed in such a way like this. I'm running a query like this. This is called a correlated subquery. Correlated. I'm going to correlate myself with my subquery. What happens? As a first cut activity, parent fetch this data. One record it will fetch. Pass to the child. Pass to the child. Child fetch, or child will apply a filter on top of this parent data by saying what? Hey, the parent have given me employee ID of 100. I will apply that filter here as 100. And the parent have given me the department ID of 100. I will apply that filter as 90. So child table dot employee ID equal to 100 and child table dot department ID equal to 90. I will apply as a filter and select just one as an output, true or false as an output, yes or no as an output. It will fetch yes or no as an output. If this where class find yes, this particular subquery returns one value for the input that I pass, then the parent query will go and fetch the data again from the table or consider the data further. So what the parent is doing, parent is taking a record, passing to the child. Child is checking in his internal database table and responding back to the parent. The parent will consider if child say yes, else it will not consider the row. This is the way how the correlated subquery works. So how many iteration it is doing? Parent fetch the data and send it to the child. Child will give the acceptance to the parent. Child will say true or false to the parent. The parent where class will check whether this data exists or not. You check child like this, will ask. Child will go and check that record. If it is there, it will say yes, I have the data. If this data is not there, it will respond, no, I don't have the data. If it sends yes to the parent will fetch that, will consider that row. So what is happening? Multi-directional query is happening. Parent to child, child to parent. Then parent will consider. Clear on this part? As Gokula told, the first part is yes, parent run and fetch the data, pass to the child. Child will confirm whether the data is present or not and respond the parent. Then the parent will use an exist condition to check whether the child has the data or not, and it will consider the data. This is correlated subquery. A pretty complex query. Not even people works in databases or SQL querying knows about this exactly how it works. It has some more nitty-gritty things to discuss, but now I'm not talking about it. Team, are you with me in this? The correlated subquery means what? For every execution of a parent query, the subquery executes. What is correlated subquery? A query depends on the outer query for its execution and result, meaning it is evaluated once each row processed by the outer query. This dependency is established because the inner query references the column from the outer query table. Correlated subqueries are useful for row-by-row comparison and calculation, such as finding employees whose salary is above their department average. So this is something like related to more, what to say, more related to the correlation that we are doing. Very, like it is not a simple part. It's a bit complex part. But take it lightly. It is confused. Yes, it is confused. You need to know further more about this. But just I'm giving an idea. The subqueries are of different types. This exist class, we still have to discuss about the importance of the exist class. Sounder. So usually subquery result will be input of the main query. But here the main query is giving the input to the subquery. There, yes, that is called correlated. I'm correlating with myself with you and you yourself with me. Pretty directly, I'm going to ask you this question, right, Sounder? I'm going to ask, hey, Sounder, do you have this remote? Do you have this remote in your home? You are going to take this remote from me and compare with your remote. Yes, Irfan, I have the remote. Then I'll consider this remote for myself. You are with me? So I take a remote and ask you whether you have that or not. If you say yes, I have, then you are going to say exist as true. If exist as true, then I'll consider. Otherwise, I don't consider. Otherwise, I don't consider. That's the core concept here. So here, first the parent will fetch a row and pass to the child. Child will confirm yes, that is there. I'm giving yes here just for a hypothetical reason. You can give one or something else here. So this subquery has to produce a result for the given input. Take this value as 100. Take this value as 90. What will be the result I'll get? Yes, it will return me 1. Agree? It will return me yes, true. I have 190. Then the parent will go and do what? Oh, this guy have given return the result for me. He have given me the confirmation. Okay, then let me consider the data from the table. Is it doing like that? That way? But for that given row alone, I want to consider. If I give just to one, it will consider every data. For that given data, whether 1 or 0, it will return. With me, team?
Irfan, I have a question.
Yeah.
I just wanted to know, so when we are working with this correlated one, the parent select query consisting of where condition, right?
Yeah.
So this where you have taken example of exist. So will it be always exist, or how many different
Exist
ways?
has a very big meaning behind why we use, actually speaking. Exist is the one what we use basically. Exist will do what, at least one occurrence of data is present in the child, the parent will fetch the data. That is the concept of exist. If I
Right. So
use
for
one here, right?
correlation,
Yeah.
yeah,
See,
I
I'm
understood that part exists, but the
Yeah.
thing is like, is it always we go with exist for a correlated subquery, or
Yes,
any
yes,
other
yes.
things
We
are
always
also?
go with exist actually.
Okay.
Because this is not going to return a value. It is going to return a Boolean condition. So if I go with the value, I'll use in. If I'm going to select the data from a table, I will use in to particularly look for a value. But if I'm going to select the data from a table, right? If the subquery returns even a result, any result it returns, I don't bother. I will fetch the data from the main table. So there are 2 ways we can write the query in general, right? Select star from employees, where employee ID in 100, 101. Like this, I can go and run a query. Agree? Or I can say where exists of some true I'm getting as a response. True, I'm getting as a response. For this also, I want to fetch the data. True means what? Something like this. But I don't want to go to that topic of what Gokula is bringing now, exist or in, which one is faster. That topic I want to talk with you guys later. But basically, there is a type of query called correlated subquery that we have. Don't worry about exist in and all this, but that is how we write the query. You go and see here. What
Right.
are
Can I think in this way? Say, suppose that second query what you have written, say,
Mhm.
suppose I have an aggregation saying, asking about like this average of so and so
yes.
salary is
Yes.
1,000. So then where that salary is greater than 1,000, then only pull something like that. Is that a valid one?
Even you can do that way. See, as I was mentioning it, but exist is better as he's mentioning, or I want to use in condition.
Okay.
In of I'm using where the salary is salary in. I'm selecting the salary here. Salary here. So do the comparison of this employee and this employee from the parent table and the child table and do this operation. But which one is more faster is the one what I'm talking about. So we mostly use the exist condition in the subquery. I mean in the parent query. That's the core concept.
Oh, thank you.
Yeah. But this exist class and all these other classes, I'll still again discuss with you guys with the performance optimization side, which one is better to use or not better to use. But here I wanted you to understand mainly the correlated subquery will be working here, like as the example we have seen, right? For every parent salary, I want to check for the sum of the salary from the like a department. So any employees who is getting the salary greater than the sum of a department salary. So I'm giving one employee a salary of 1 lakh, but for a department itself, the total salary itself I'm giving for the employees as only 70,000. So is there one employee who is getting a salary more than a department salary that I'm offering to them? So I can use such kind of queries here. Here I can use the department wise salary I can calculate and I can pass that as an input to this main parent table like this and all. We can do the correlation subquery to achieve a lot of outcome. But the general point what we do is we use exist function to at least check whether the given occurrence of the data is present in the child table or not. That's how it works actually. Okay. But the correlated subquery is very challenging one. Just I'm giving you an idea. Even in this query, I did not brought that even like because of it is complex. Okay, so now let us go and you guys can use these queries to understand, right? Select employees where average salary is greater than, which are all the employees who is getting the salary more than the average salary of the employee table. Average salary of an employee we have is 50,000. Some of the employees who is getting more than the average salary. So the purpose of going with subqueries. So here we are going with the subquery, right? The average salary will return only one result. So we can directly use a condition to check. Equal to or greater than or whatever the condition. If this return multiple result, salary alone if I choose, then this query will fail by saying what subquery returns more than one row. In that case, we have to use in condition. The purpose of using in is used for multiple result to handle. Just a greater than symbol I can use to say, hey, one result if it is returning. I'm very sure, right? Average will be returning only one result. So I'm running a subquery. The result of the subquery has to be provided as an input to the parent query for generating the output from the parent. This is a normal subquery. But correlated subquery, parent will fetch a data, pass to the child, child will respond to the parent, then the parent will retain the data or have the data used. That is correlated subquery. I'm correlating with me, with the other. I'm correlating. Here, I'm asking, hey, you have something to provide and compare with me? Yes, you can compare. I'll fetch whichever is greater than your value or less than your value. That's it. That is basically the usage of subquery. So you got an idea. This is called subquery in general, guys. Yeah, go ahead, Ravani.
Yeah, sorry, Irfan, maybe I missed out
Yeah, sorry,
something.
sorry.
So if you go back to the screen of that one execution, right? So can you once tell me a glance of like what will be the order of execution? Usually
Okay. In
select
this case,
star from table means
okay.
from table.
In-
Yeah,
Yeah,
give
in
the
this case,
comparison of both.
child will run and produce result to the parent. Then parent will run. How to
Right.
understand?
I have a question here, Irfan. So
Yeah.
usually if you write a normal query, right, select star from table, usually after the from clause, what are the tables? Those tables will be loaded into the memory, right? How the SQL architecture or
So
something will
actually,
take.
if we see here, how it will run is basically the from will be running with the where
Mm,
class applied on it, right? So here what
right.
will happen, even this also is going to do in the same way only. Here, the from will be executed from the innermost query.
That means order of execution will be there from right to left. Uh,
In this case,
and
actually, in the subquery case, if you use subquery, it will be running like this. The subquery will run first, then the parent query will run second. The reason behind, I'll tell you. Do we know the value of what is the salary I have to substitute in the where class to make this query completed? So this query will be divided into two queries basically. One is
okay.
parent query and another one is subquery.
So
What is
system identifies whether it is a main query or subquery.
correct, correct. Whether it's a parent query or subquery, it will identify. See, basically, not to
Okay.
run this query, you ask me this, answer me this question. To run this
Mm,
query, do we need this value?
right.
If I'm going to run a query like this, will it work? Will it work?
I mean, by execution, I know it, but how system get to know
Yeah, that's what
whether
I'm
it is
telling.
a main
See, that's
query?
what I'm telling.
Okay.
Even system have to execute this. He need the full information to run. Agree?
Mm,
Agree? So he need this value to be substituted here to run, right? Otherwise, how can he run? So for that, what he will do? First, he will run this query and get the result. What is the average
okay.
salary? First, he will. That's what I'm trying to say. First, the system will split the dependency. Will identify the dependency. Okay, first I need the average salary from employees. Then only I will substitute this value to the where class of the parent query. Then this query is in a full state of ready state, right, to run. Agree?
Right.
You
Okay.
are now getting it. Why this is running first?
Right. Right. Now
Okay.
let's go back to that correlated subquery.
Yeah.
Here,
Now
how
you
the
go here.
dependency gets identifies.
Yeah.
Yeah.
You just say now in order to run this query, can this query alone can run?
Yes, it can be run.
How? Without this value, how it can run?
Which one?
I'm
Oh, okay.
depending on my
Where
parent, right?
clause?
Yeah. That's where first the parent will come. See, you are saying the query is going to run with the from, then the where. But after
Right.
from, it will stuck here, right? It will not further proceed here. To make this query
Okay.
completely run, we need even this where class also. Internally, it is going to first run from, then where, then select and all. That's a different story. But
Okay.
to
So the
complete
order
this
of
entire query,
execution will look for a dependencies also. Then
yeah.
it will
See,
formulate.
first
Okay.
I have to know whether this complete query can run. What are the dependencies that I have for that? So to run this entire query, what are the dependency? Can you say this query even? He needs the parent's employee ID and parent's department ID. That's where the parent will first run that and get that one record and pass to here. Substitute the value here. Then with this value substituted, that's where I put 190 and show this here. Then the child query will run. Then the child will provide the response to the parent saying exist or not exist. Then the parent will retain the data or don't retain. So multi-directional. Is it running? Parent pass to the child. Child will run and responds to the parent. Then parent will retain the data. But whereas here, it's pretty direct. In order to run this query, all I need is what? This value I needed. So first this query will run and produce the value. Then that value he will substitute and run the further query. Further query will run first employees, then where, and then select. That order will still retain everywhere. No doubt in that. Clear?
Right.
Clear? But great, you guys are thinking in this much lower level. Great thing. Great. I appreciate it. Right? I mean, like no other chance. We have to think in this way once for all to confirm. That is the analytical thinking. The data wise, if you think something, this is analytical thinking. You have to either put it in your brain and think, or you have to put it in a paper and think. Anyway, you have to get this understood, right? But subquery is a pretty interesting concept. Plays a very vital role in the SQL queries that we work. So inquiry, when do we use in? Can you guys answer me, guys? When do we use in? When the result is going to be multiple, then we use in. When the subquery is going to return multiple result, then we use in. Right? So this query may return multiple results. So I got to get all the department IDs substituted in this in class. So here I am going to get all these department IDs substituted 10, 30, 90. You imagine like this, you can get the answer. With me, guys, what I'm speaking? So it's a single column. When do you use in class? If the child query returns multiple result, we use in class. Okay, what about this one? Exist class, when do we use? When we use correlated subquery. So take this example, right? When using correlated subquery, we'll use this one. But this has a big meaning behind scene. We will discuss even further. What is the question here? Find the department that have at least one employee. So I'm going to put an exist condition to say minimum one employee should be there in the department. Those data I wanted to collect. So I'm going to pass a department ID to the employee table, which minimum at least this employee table contains this department ID for any one of the employee. Then that department will be returned back. In general, the department table contains lot of departments. You agree that, right? You know that. There are around how many departments are there? 28 departments are there overall in this department table. But I want to know, hey, which are all the departments that has at least one employee within them? So I'm going to ask, hey, let me pass the department to you, the employee table. You go and put the department ID here and check whether you have that department, some employees in your the department or not. If so, return just true or false to me. If any one employee exists also, I'll consider that as my department. So here you can put in also, but in is very costly. In I can put here and say, where department ID in, I can put select e.department ID. But this is a very costly solution. So every record it will go and collect from here for the given department ID and pass that as an input to this department ID. I'm just telling what, hey, minimum one employee if he present also, at least one employee in a department we have also, you can return me that result I'm asking. It's a matter of interpreting the English. Very directly it is an English. How to convert that English to a query? That's a part. So I'm telling you just give yes or no. Give me a signal, yes. If exists, you give me yes. If not exists, don't give me yes. So this yes will be returned. Yes will be returned for the given department ID what I pass from the department table. So the department table is passing a ID called 30. The parent table is passing ID as 30. So this guy will return yes. Minimum one yes exists. This guy is returning this many number of departments in this employee table. The people are working in this department. This many employees are working, it will say. But this exist characteristics is what? At least one time I get a yes. I don't consider the rest of the yes and all. That is the benefit of this exist function. With me? It won't wait for all the yes to be returned. One yes it will see, immediately it will go and ask the department to consider this department ID 30. That's what it is going to do here. You see? The 30 will be considered because the 30 is taken by the department and passed through here to get this fulfilled. Then this guy will substitute that value and make this query executed 100%. Then this query will be executed with this exist value. So it's a kind of a correlation what we are doing. Yeah, kind of a looping connection we are doing. Right? Parent to child, child to parent. Then the parent will fetch the data. That's why this query is something special. Not a very simple query to understand. I know like this query is not easily understandable. And we spend sometime in this query further also. Not exist. The other question, find departments without employees. But we can achieve this by using join also, by using subquery also, by using the correlated subquery also. All can be used here. Right, team? Join also we can use here. Any operator, all operators and all are there. Any operator represents what? It is almost similar to exist, but any one value, if it is matching with the data, it's not exist, is going to return Boolean, true or false. But there is some special function called any function is there. I'm going to say, hey, take the salary of the employee table, take the record from the employee table whose salary is at least, greater than any one of the salary of the employee table with department of 60. Just see this, right? This query. I'm having the employee department 60 salaries returned to me. I'm going to say, select the data from the employee table whose salary is greater than any one of the salary, not all the salary you compare and all. Any one of the salary, take one salary, 9,000 as a salary. The employees who is getting more than 9,000, you display from the employees table like this, I'm telling. So it is going to display the salary with any of this greater than. All of this greater than, I can give all as a function. So all the, consider all the values of up to the 9,000 is the maximum value, right? Anything more than that value alone, I want to consider. Not any. Any means, like any of the salary, whatever in this department, you can consider like greater than 9,000, greater than 6,000, greater than 4,200 also you consider. But all, that means what? This subquery is returning this 9,000, 6,000 and all this value. Anything or all greater than this value you have to consider. The salary of the main employees has to be greater than all this. Consider all this value. So 9,000 is the maximum value in that department of 60. So it will consider 9,000 greater than anything greater than 9,000 will be displayed from here. So the all and any you can consider, but it's not very important and all, right? Do you remember this query, guys? Union query. Union, all. Union we talked about in Python. Do you remember? It's a set operation query, right? So we can join the data between the tables row wise, but I want to join the data column wise, something like this. So basically the join can happen like this, right? I have the data like this and this. I'm going to join these two data sets. How do I join? Like this. I'll produce the widened result like this, right? I'll have something like this. Agree? So when I join the data between two tables, the number of columns will be expanded. Number of columns will be expanded. Number of rows will be with the maximum number of rows what is present in a table, that rows will be considered if I do full outer join. Or in left outer join or whichever. But whereas in the case of union, when I do, the number of columns will remain same, but the rows will be extended. The number of rows between the table will be extended. I have table 1, table 2. I'll be unioning them. So I'll attach like this, right? You remember the union we discussed? But there are some thumb rules between the union. The number of columns should be same. The data type of the column should be same. So if I take department name, I'm just going to do the union between department ID and department name. What is happening here? It is returning with the heterogeneous data. So what I had to do, I had to convert this also into an, cast it as a string data type. So I had to make it as a same data type in general. Care of or whatever the function, I have to make it off. Otherwise, it works, but it is going to result me in a wronger result in a later point of time. Oh, character conversion it is showing, right? Somebody is not muted. Okay, Sujata, I'm putting you on mute. Okay, guys. So the union can be done between the tables, and there is a one more important point to consider. Union all is there. Union versus union all. And in BigQuery and all, we have something called union distinct. We learn about this and all subsequently. And here also they started supporting it seems. Take the distinct data between both the tables and make it as, or I mean, take the data between both tables and union them, and but don't show duplicates. Like this and all, we have different types of union functionalities that is available, but that will do what? If I have a table with 100 rows, another table with 20 rows, what will be the union result? 120, right? If I have duplicates in the data, maybe 10 records are duplicate, it will eliminate the duplicate. That is the concept of union. Okay, but there are some thumb rules are there. Select star from employees, union, select star from department if I do. Will it work? Will it work, guys? It won't work. It will say the column should have same number of columns. So I don't work. So employee contains some set of columns. Maybe how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns are there. Department contains how many columns? Only 4 columns are there. Then what I have to do? I have to go and say, hey, make both of them as either 11 or 4. So you choose only 4 columns from the employee table and you do the union. It works. Here it works. Otherwise, it won't work. That's the core thumb rule. So like union, we have union all, which will provide the duplicate also. See, if I have chosen without duplicate, right, it shows only the 1, 2, 3, 4 one time. But if I go with duplicate, union all, it will return the data with duplicate also. We have something like intersection, subtraction, minus and all. We learn about it in the later point of time with the other query layer that we learn. But for now, you can consider this. Union all. The nested subquery concept we have, as people were telling about. We can go with the subquery and we can have one more subquery inside that as well that can be created. So basically, this is one of the very important interview question asked. Can you show me the employee of the salary who is getting the salary more than the other employee, or who is the top most employee? Who is the top salary consuming employee? Like this, if I ask. Right? So I'll go and do what? I'll put a subquery and calculate the maximum salary of a given employee in a table. Right? Then more than this maximum salary, which employee is getting the salary? That I want to check. I can do like this and get the result. Or I may say, select the maximum salary of the employee from the subquery, and I can go with where the salary is greater than one more subquery I can write. So this is what type of query I'm writing? Nested subquery I'm writing. A subquery inside a query inside a subquery. Then inside the subquery, I'm writing one more subquery. So you can see here what I'm doing is basically I have a parent query. Inside that I have a subquery. Inside that I have a subquery. And that subquery has one more subquery inside that. You can see like this. This is the subquery of the parent query. This is the whole subquery of the parent query. Inside the subquery, I have one more subquery. If I do like this, this is called nested subquery. So the topmost employee who is getting the package, anything more than all the other employees. That's what we are finding here. So find the maximum salary of department ID 60. Then more than the department ID 60, what is the maximum salary? And who is that person? Just find that. I'm just telling those. So the topmost person is the Stephen King, who is the owner of the company. I can get this data. So this is called something like, I mean, I'm just not going with the scenario here. Just find this nested subqueries. The subquery having one more subquery like this, you can nest and go. Okay. So take it lightly in that way, guys. So whatever we learned is a very important topics for minimum knowing about the querying concept. Don't go with the scenario. Just know what are all the ways you can write queries. Then we apply the scenario separately. I have a couple of those kind of questions to discuss with you guys, as I told you earlier, right? I mean, we are running on top of the hour. Maybe I'll share you this query. You try this. Then we'll again connect on this and discuss. Maybe not on a regular SQL session. We'll go with the regular session itself, applying this in our broader environment, not in MySQL. We'll apply this in our BigQuery or Synapse or those kind of, even in Spark and all. And these are all the DDL queries. Please try to understand until these queries at least, what I'm highlighting, right? And you can understand about some alter table queries also, that is fine. DML statements is all about insert, update, delete and all. Whoever is not having any idea on this, please try this. Maybe the transaction control is not much important for our, for us at least, because this is not applicable in the cloud or in our big data platform and all. But until here, at least you consider how to perform the operations, including the truncate table, the DML and all. Okay. So try all these guys and try to get some basic idea. If you guys needed some support on this further, whoever is a bit weak in the SQL, we will connect separately and I can help you to solve. Okay. I'll upload this sheet in our drive. Okay. The drive already have the sheet, but this is not that's not the updated sheet. I'll upload tonight. Okay. Great team. So please, work on this. Get familiarity in the SQL syntactically at least, semantically at least, not in the scenario wise. Scenario wise, we will discuss again. Okay. In a broader scenario, we discuss. Again, it requires some iteration. Okay. But minimum at the time, you should not say, Irfan, I'm a bit stuck in writing joins. I'm a bit stuck in writing subquery. What is this? You should not ask me. Like when I write like this, you should not ask me, Irfan, how is it possible to write like this? You should not ask me. Okay. So all possible way of writing subqueries. I'll just give here whatever we learned.
Irfan, is it possible to have one more session, something on the CTs and Windows functions?
No. CTEs, Windows functions and all, we will learn in our regular part of the discussion.
Okay.
We heavily learned it. We spend not 2 hours, 3 hours like this. We spend at least few days on that. Don't worry.
Okay.
Okay. Definitely we are going to spend on that. That is a part, that is the actual part of our learning actually. Okay. So if you see here, like in the Spark and everywhere, we are going to do that activity. Okay. Don't worry. See what I'm telling you, simply leave it to me, right? Simply leave it to me. You don't worry about Irfan, can you cover this or that and all. I will cover exactly what is needed to you. But here, what I covered, you just get some familiarity, right? I know this even we did not find a huge time to cover very fundamentally, very lower level. I just covered at bit higher level, bit faster even. But I hope you guys can try this one from your side also, right? To get some idea. Agree, team, what I'm speaking? Right? So that's where I told here, this one, we'll be going with those kind of advanced thing also, that common table expression, or using the aggregate functions, analytical function, windowing functions. All this we use, but I don't find time to talk about this one completely with you guys. Time in the sense it is a big part actually. We have to spend a lot of time in learning it. But minimum, I wanted you to get ready on this. One thing I'm trying to say, right? Why I had this session, I'll tell you guys. The reason behind. Trust me, for another 6 months, we are going to learn SQL only. But different concepts of SQL, different interesting concepts of SQL, we are going to learn. Trust me, first thing. Second thing is, why I conducted this session then. When I talk about that the broader session, you should not ask a Irfan, wow, how you can write a query like this? What is this is called as? You should say, no, this is called subquery. Oh, can I have more than 2 columns in a subquery? Can I have more than 2 columns in a subquery? You should not ask me. Oh, yes, I remember we have seen some multi-column subquery. Can I have a subquery with the parent query execution? You should not ask me. You should say, yes, I remember something called correlated subquery. You are with me? So you have to be up to speed in along with those people, along with those, like our regular people who have some knowledge in SQL already. Even they will not be having a clear-cut knowledge on this. But if I pull them in a general session like this, right? I mean, like if I talk about this in our regular session, right? They'll be feeling like, hey, already I know this why you are talking. But not everybody knows that. Even they will say, I know that, but they will not be having a very good clarity on this. So I'm just giving you a kind of a curated clarity for you guys on this, okay? But this will take some time to learn. I mean, whatever I covered is the content which we can learn for a couple of weeks actually. But I don't want you to worry that much level lower, okay? Whatever I covered here, are you guys trying with this? That's the only question I want to ask to you. Please do that. Please take this and try sitting and spending some time on the data, understand the data, try to apply that and try to learn basically and have your readiness. After we go into our actual data management techniques and everything when we do, we will be learning a lot of these things in a multifold fashion. By the time you will get a very good clarity of learning. Okay. So trust me guys, that's even I did not teach 4 sessions of SQL to my previous batches now, including the 2 video plus 2 days session, right? I did not teach you that. You remember yesterday, our Vaishali was telling, right? You guys remember in the weekday batch who came yesterday? Did you guys hear that from her? Irfan, for us and all, you did not teach the SQL, right? I mean, like somebody else have taken SQL for one hour just for the sake of making the people understand SQL. We did not given this much documentation, but I'm giving you guys make use of that, right, Mohan? Even I did not conduct that SQL session at all, even, right, Mohan? Yeah, see, Mohan is telling he was my old batch member, right? So this much level I covered here, but do we learn SQL in our regular session, Mohan? Not in this way. Bit one more level down, lower level way we learn. Agree, Mohan? Spark SQL or Hive SQL, BigQuery SQL or whatever, Synapse SQL. Maybe at the time you did not attend BigQuery and all, right? Agree? So we will learn actually. But we learn that big data oriented SQL, external tables, SERDs, those kind of concept, managing of semi-structured data, those extended level of learning we do, but there also we apply all the SQL only. The SQL basics is needed there. Okay, team? Don't worry. Don't worry. I will take care, leave that responsibility to me. Okay. Just follow only this level of queries what I have given you for now. With whoever don't have an idea about this, this is a foundational session. Again, I'm mentioning it's a foundational session. Okay. But please get into this, guys. Get ready on this. Okay. Thank you, team. Anything else? I know we are on top of that, guys. Enjoy your rest of the day. Yes, this will also be added in our list and I'll share you guys. Okay. Please go through. Don't worry. Just try to learn whatever you can, right? I will help you guys on the rest. Maybe weekday team, I'll extend some time in the weekday to help you. If you guys come back with the questions, asking Irfan, I tried this SQL, it is not working. I'm ready to help you guys. Okay. Great. I'll be giving some SQL in the command-based mode also soon in a form of VM. Don't worry, guys. Okay. So just try to do whatever you can on this. Okay. Don't think like I have to know everything, guys. Okay. Be very clear. Thank you, team. Thank you for your time and efforts. Just try this SQL. Okay, that's like a mother tongue, as I'm telling. Okay. Thank you, team. Thank you all for your time, extended time. Tomorrow morning we'll meet, guys. Weekday team. Thank you all. Thanks, guys.